Good evening, and welcome to the Sleepy Geographer. Tonight's journey drifts into the quiet but powerful story of drought, the times and places where water disappears and the land is left waiting for rain. Before we begin, I would love to know where in the world you're listening from. It is always fascinating to see the places this channel reaches. If you enjoy these calm wanderings, a gentle like and a subscribe would mean a lot. And to those who are already subscribed, thank you kindly for being here once again. I do hope this video is soothing enough to help you unwind, though there is always the chance it might be just interesting enough to keep you awake for a little while. If that happens, at least you will be drifting off with a few new pieces of knowledge tucked away. So settle in, let the mind grow still, and let us ask a simple question. What really happens when the earth runs dry? Drought is often thought of as a desert stretching endlessly to the horizon, but the truth is more subtle and complex. A drought is not always a place without water, but often a place that has lost the balance it once held. It can strike almost anywhere, from rolling farmland to mountain valleys, from river deltas to forest edges. What links these varied landscapes is a temporary absence, the rain that does not come, the rivers that shrink back, the reservoirs that dip lower each day. To understand drought, one must first separate it from permanent dryness. A desert is a region shaped by long-term scarcity, an arid environment woven into the climate itself. Drought, however, is the interruption of the usual rhythm. It is when the expected rains are late, when the riverbed is suddenly silent, when the crops wither not because they cannot grow there, but because they have been left waiting. In this sense, drought is not only a physical condition, but also a disruption of trust between land, sky, and people. The story of drought stretches across time and space. Ancient civilizations rose and fell by the grace of rainfall. Farmers measured their hopes in clouds, nomads followed the promise of springs, and whole communities carried with them the memory of seasons when the earth was too thirsty to yield. In the modern world, drought still arrives with quiet persistence. It may not be as sudden as a storm or as dramatic as an earthquake, but its impact seeps into every part of life. It can strain food supplies, weaken rivers that once powered cities, and test the resilience of entire societies. This journey will not only look at why rain sometimes fails to fall, but also at how the earth responds in silence, how soils crack and plants cling on, and how people have learned, and are still learning, to adapt. We will wander from ancient records written in tree rings to modern satellites watching the sky. We will see how cultures have found resilience in scarcity, and how the natural world bends, sometimes breaks, under the long weight of thirst. At its heart, drought is a reminder that water is never guaranteed. It is a lesson in fragility, in patience, and in the enduring ties between climate and life. To follow the geography of drought is to understand not only where water disappears, but also what is revealed when it does. Drought is a word that sounds simple enough. At first glance, it seems to mean little more than a shortage of water. Yet when geographers, scientists, and farmers use the word, they are often speaking about very different things. The term can mean dry skies, empty rivers, stunted crops, or even economic hardship rippling through a community. It is a single label pinned onto a set of interconnected but distinct experiences. To really understand what drought is, it helps to unpick its many layers and see how each definition captures a different perspective on the same unfolding problem. The first lens is meteorological drought, which is the easiest to picture. This is the kind of drought most people imagine when they look at a clear sky that should be pouring with rain. Meteorologists measure it by comparing how much precipitation has fallen against what is considered normal for a particular place and season. If a region expects 50 millimeters of rain in a month but receives only 5, that is a meteorological drought. It is essentially nature's broken promise. Of course, what counts as normal depends greatly on geography. In London, a few dry weeks may hardly register, while in parts of the Sahel such a shortfall can quickly become life-threatening. Meteorological drought is about timing and totals, the simple arithmetic of clouds failing to deliver. But rainfall alone does not tell the whole story. A region can have relatively normal precipitation and still experience what is called hydrological drought. This form is tied to the broader water system, rivers, lakes, reservoirs, and underground aquifers. Hydrological drought takes longer to appear because it is about supply across the landscape. Imagine a river that has been fed by melting snow in the mountains. If an unusually warm winter leaves little snowpack, the river may trickle instead of roar when spring arrives. Even if it rains in the valleys, the missing snowmelt starves the river. Hydrological drought is the depletion of surface and groundwater stores, the silent lowering of water tables, the shrinking of lakes, and the slow retreat of reservoirs. It is a kind of delayed echo of meteorological drought, appearing after months or even years of subtle imbalance. Then there is agricultural drought, which brings the human relationship with the land into sharp focus. Farmers may not care how many millimeters of rain the meteorologist recorded, if their soil is dry and their crops are wilting. Agricultural drought describes the point at which soil moisture is insufficient to sustain plants. Crops may germinate but fail to thrive. Pastures may thin, and livestock may struggle to find enough to graze. This definition links water shortage directly to food production. It is influenced not only by rainfall, but also by land management practices, soil type, and the demands of particular crops. For instance, maize is far more sensitive to dry spells than sorghum, so the same weather can produce a crisis in one field, while leaving another relatively unscathed. Agricultural drought highlights how the same sky can mean different fates depending on what grows beneath it. Finally, there is socioeconomic drought, which stretches beyond the fields and streams into the fabric of society. This is when the shortage of water starts to affect the availability of goods, services, and livelihoods. In this definition, drought is not simply about clouds and soil, but about economics and inequality. A city may have enough water for basic survival, but if the reservoirs are too low to support hydroelectric power, industries may grind to a halt. Farmers who lose harvests may leave the land, swelling urban populations and straining city resources. In some cases, water scarcity becomes tied to political tension or migration. Socioeconomic drought captures the ripple effect, where what began as missing rainfall cascades into shortages on supermarket shelves, rising prices, and even conflicts over access to wells and rivers. These four definitions, meteorological, hydrological, agricultural, and socioeconomic, may seem like neat categories, but in practice they overlap and bleed into one another. A lack of rain may trigger soil dryness, which stunts crops, which reduces income, which in turn places pressure on families and governments. One form of drought slides into the next like dominoes in slow motion. This interconnectedness is why scientists often speak of drought as a complex hazard rather than a single event. Unlike a hurricane which roars in with a clear beginning and end, drought creeps quietly and has no sharp boundary. The human experience of drought also depends heavily on expectations. In a desert, people may see little rain in a year, yet this is not described as drought because it is the norm. Drought is, at its heart, a deviation from what is expected. That is why definitions differ so much from place to place. A rainy English countryside may call a few weeks without showers drought, while in the Australian outback that same span would barely raise an eyebrow. Context matters, and so does culture. What feels like crisis to one community may be little more than an inconvenience to another that has adapted to scarcity. The slipperiness of the term can even cause problems in public communication. When news headlines announce a drought, they often mean the meteorological sense: rain has not fallen. Farmers, however, may already have been speaking of drought for weeks because their fields are dry, while city planners might not sound the alarm until reservoirs drop below a critical threshold. The same word masks different timelines, leading to confusion and sometimes frustration between those who monitor the sky, those who till the soil, and those who manage urban infrastructure. Another subtlety is the question of duration. A single season of low rainfall might count as a meteorological drought, but have little long-term effect if rivers and aquifers remain full. A multi-year deficit, however, can push systems beyond recovery, turning short-lived agricultural stress into structural water scarcity. Some scientists even distinguish between short flash droughts, which develop rapidly in a matter of weeks, and prolonged droughts that can last for decades. Both are real, both are damaging, but they manifest differently. Perhaps the most important lesson in looking at drought through these definitions is that it is not a single story, but a spectrum of experiences. It can be measured in millimeters of rain, cubic meters of river flow, tons of wheat lost or families displaced. Each perspective reveals something valuable, and none captures the whole. That is why geographers and climatologists treat drought as a multifaceted phenomenon, one that requires collaboration between weather forecasters, hydrologists, farmers, economists and community leaders to fully understand and address. It is almost ironic that something defined by absence can contain such a variety of meanings. Drought is empty skies and parched soil, but it is also anxious markets, displaced families, and lessons in resilience. To ask what is drought is to open a doorway into a web of science and society. The word itself may sound dry, but hidden within it are stories of rivers, farms, and cities, of expectation and surprise, of fragility and endurance. It is a reminder that geography is never just about landforms and weather charts, but about the lived reality of people and the environments they inhabit. So when we speak of drought, we're really speaking of a layered silence, the silence of skies without rain, the silence of rivers without flow, the silence of fields without harvest, and sometimes the silence of livelihoods paused in uncertainty. This one word holds them all, and that is what makes it such a powerful and sometimes misunderstood feature of our world. Water moves through the world in an endless dance, slipping from cloud to earth, from soil to river, and back to the air again. This is the water cycle, one of the planet's most graceful balancing acts. It is so constant and so familiar that it is easy to overlook its delicacy. Yet, even the smallest nudge in this cycle, a little less rainfall, a touch more evaporation, or soil too hard to absorb the gift of rain, can have consequences that ripple across landscapes and societies alike. It begins, of course, with precipitation, the skies offering to the earth. Rain is the most obvious, but precipitation comes in many guises. Snow drifting onto mountain peaks, hail clattering onto fields, sleet stinging in winter winds. Even mist condensing onto leaves and cloud forests is a form of precipitation, as delicate as it is vital. The amount, the timing, and the distribution of this falling water are what determine whether a region is lush, dry, or something in between. The catch is that precipitation is never perfectly predictable. Some years are generous, others miserly, and in that swing lies the seed of drought. When water does reach the ground, its journey branches in several directions. One portion infiltrates the soil, seeping into the spaces between grains of sand, silt, and clay. Infiltration is the quiet beginning of groundwater, replenishing the aquifers that store water like hidden treasure beneath the surface. A sponge-like soil rich in organic matter soaks up rainfall, holding it for plants to sip slowly. In contrast, compacted or overused land behaves like a hardened crust, repelling rain and forcing it to run away rather than sink in. This simple difference can decide whether a sudden shower nourishes crops or rushes off in a flood. Another fraction of rainfall becomes surface runoff, streaming across the land into gullies, rivers, and eventually the ocean. Runoff is both friend and foe. It is how rivers gain their flow, carrying water across continents and giving life to valleys and plains. But when runoff dominates over infiltration, it can wash away fertile soil and fail to recharge underground reserves. Urban landscapes with roads and rooftops are especially prone to rapid runoff, channeling rain into drains before the earth has time to drink. Meanwhile, water is always on the move upward again through evaporation. Sunlight coaxes liquid back into vapour, lifting it invisibly into the air. A single square metre of ocean can release litres upon litres of water into the atmosphere on a warm day. On land, plants join the process through transpiration, drawing moisture from the soil and releasing it through their leaves. Together, evaporation and transpiration are often called evapotranspiration, a constant gentle exhalation of the biosphere. Without this rising stream, clouds would not form and rain would never return. What makes the water cycle fragile is the need for all these parts to remain in balance. Imagine a seesaw. If precipitation outweighs evaporation, rivers swell and wetlands spread. If evaporation outpaces rainfall, lakes shrink and soils dry. A shift in infiltration or runoff can tilt the system too. For example, deforestation not only reduces transpiration but also hardens the soil, decreasing infiltration and increasing runoff. The same rain falling on bare land produces a very different outcome than rain falling on forest. Small changes accumulate into big effects. A region that experiences just a little less rainfall than usual may see reservoirs drop more quickly if evaporation is also higher due to hotter temperatures. Farmers may notice crops wilting even when rain totals appear close to normal, because infiltration has declined after years of overgrazing. Cities may face shortages when snow in distant mountains melts too quickly, rushing away in floods rather than feeding rivers slowly through the summer. These are all examples of how drought can emerge not from the absence of water altogether, but from subtle imbalances within the cycle. The water cycle also moves at different speeds. Some parts are rapid, like a summer thunderstorm evaporating within hours. Others are measured in decades, such as deep aquifers slowly filling with infiltrated rain. When a drought strikes, the fast parts of the cycle react immediately. Rivers dwindle, plants wilt, while the slow parts may keep supplying water for months before finally revealing their depletion. This time lag is why droughts can feel like creeping hazards, their full severity only revealed once the deeper stores have been drained. It is also worth remembering that the water cycle is not uniform across the planet. In the tropics, rainfall is abundant and regular, while in subtropical zones, descending dry air suppresses clouds and reduces precipitation. Mountain ranges can wring moisture from winds on one side, leaving a rain shadow of dryness on the other. Polar regions lock much of their precipitation as snow and ice, recycling water at a glacial pace. Each landscape has its own version of the cycle and its own vulnerabilities to imbalance. Even oceans, which seem infinite, are sensitive participants in this cycle. Warmer seas evaporate more quickly, feeding storms in some regions while depriving others. Shifts in ocean temperatures during El Niño and La Niña events can rearrange rainfall patterns thousands of kilometers away, delivering floods to one coast and drought to another. The cycle is global, knitted together across continents and seas, yet experienced most intimately in local fields and villages. Humans have long sought to harness the cycle, building canals, dams, and irrigation networks to capture rainfall and direct runoff. In some cases, this engineering has stabilized supplies, but in others it has tipped the balance further out of line. Overpumping groundwater, for example, can extract centuries of stored water faster than infiltration can replace it. Once these reserves are gone, no amount of seasonal rain can quickly restore them. This is where human geography meets physical geography. This cycle provides the stage, but human choices determine how fragile or resilient it becomes. The poetry of the water cycle lies in its repetition, the eternal journey from sky to land to sky again. Yet the reality is that the cycle is not unbreakable. It relies on delicate equilibriums, and when those are disturbed, the consequences emerge in fields, rivers, and households. Drought is, in many ways, the visible sign that this balance has faltered. It shows up when the ledger of precipitation and evaporation no longer balances, when infiltration is too low, or when runoff races away unchecked. Understanding the water cycle as a fragile balance helps explain why drought is never just about empty skies. It is about the entire system tilting, sometimes imperceptibly, until the effects become impossible to ignore. In that sense, the story of drought begins not with catastrophe, but with the quiet mathematics of raindrops, soil pores, rivers, and sunlight. Out of such small exchanges, entire landscapes of abundance or scarcity are shaped. The absence of rain is not always a matter of chance. Skies can stay stubbornly clear for reasons that are written into the great machinery of Earth's atmosphere. Winds, pressure belts, and vast oceanic rhythms decide when and where clouds gather or disperse. To understand why some places are parched while others are lush, one has to look not only at local weather, but also at the grand patterns of circulation that move air and water around the globe. At the simplest level, rainfall happens when moist air rises, cools and condenses into droplets. If the air does not rise, or if it is too dry, rain will not form. That seems straightforward, but the reasons air behaves this way are tied to invisible but powerful forces circling the planet. Chief among them is the uneven heating of the Earth. Near the equator, the sun's energy is intense, warming the air and encouraging it to rise. As that air ascends, it cools, moisture condenses, and frequent downpours drench the tropics. This is why rainforests thrive along the equator. However, that rising air does not stay put. It travels poleward and eventually sinks back to the surface around 30 degrees north and south of the equator. When air descends, it warms and dries, creating belts of high pressure known as subtropical highs. These are the engines behind many of the world's great deserts, from the Sahara in Africa to the Australian outback. In these regions, clear skies are the default, not the exception. The sun blazes, clouds are discouraged, and rain becomes a rare guest. This is a planetary scale circulation known as the Hadley cell, and it explains why dry climates are arranged in such a neat band across the globe. Winds are also sculptors of rainfall patterns. The trade winds, for example, blow steadily from east to west in the tropics. They carry moist air across oceans, feeding rainfall on windward coasts but leaving the opposite side, the leeward side, in rain shadow. Mountain ranges exaggerate this effect. Moist air forced up a slope cools and condenses, dropping rain on one side, while the descending air on the far slope warms and dries, creating parched landscapes. This is why lush forests and arid deserts can sit side by side, divided only by a ridge. Beyond these steady patterns, there are rhythms that pulse over years, tipping rainfall first one way, then another. One of the most famous is El Niño, a periodic warming of the eastern Pacific Ocean. In a typical year, trade winds push warm surface waters westward toward Asia, while cooler water wells up along the coast of South America. During an El Niño, those trade winds weaken, and warm water sloshes back toward the east. The shift disrupts rainfall patterns worldwide. Some regions, such as Peru, experience torrential rains, while others, like Indonesia and Australia, endure drought. It is as if the Pacific has thrown a stone into the atmosphere, sending ripples that rearrange global weather. La Niña is the opposite swing of this pendulum. In La Niña years, the trade winds strengthen, piling even more warm water toward the western Pacific, and allowing cooler waters to dominate the east. This can intensify rains in Asia while drying parts of the Americas. Together, El Niño and La Niña form a seesaw known as the El Niño Southern Oscillation, or ENSO for short. Communities across the globe watch these cycles carefully, because they so often dictate whether crops will flourish or wither, and whether rivers will swell or shrink. There are other oscillations too, quieter but still influential. The North Atlantic Oscillation alters rainfall over Europe and parts of North America. The Indian Ocean. Dipole shapes monsoon behaviour across East Africa and the Indian subcontinent. These systems reveal that drought is often not a matter of unlucky weather, but of distant oceans and shifting winds dictating who gets rain and who does not. High-pressure systems also play a sneaky role in keeping skies empty. Unlike low pressure, which encourages air to rise and clouds to form, high pressure pushes air downward. This descending motion acts like a lid, suppressing convection and locking moisture out of the sky. When such systems linger, they can create extended dry spells. Southern Europe, for instance, often experiences drought when a strong high-pressure ridge settles over the Mediterranean, deflecting storm systems northward. Similarly, the so-called blocking highs can sit stubbornly in place, forcing rain-bearing weather systems to detour around them, leaving the land beneath starved of water. The story is further complicated by temperature. Warm air can hold more moisture than cool air. When global temperatures rise, the atmosphere becomes more of a sponge. In theory, that could mean more rain overall, but the distribution is uneven. Wet places may become wetter, while dry regions grow drier as evaporation speeds up and subtropical highs intensify. The result is that droughts can deepen, even in a world with more moisture in the air. It is less about how much water exists on Earth that has not changed, and more about how the atmosphere chooses to move it around. An evocative example comes from the Sahel, the band of semi-arid land just south of the Sahara Desert. The Sahel has long been at the mercy of shifting rainfall. In the 20th century, decades of drought devastated the region, driven by changes in sea surface temperatures and atmospheric circulation. The rains did not simply disappear at random. They shifted north and south depending on the subtle balance of heat between oceans. To those on the ground, the result was empty wells and failing crops, but the root cause lay in the vast tug-of-war between global climate systems. From a human perspective, the dry sky feels immediate and personal. Crops wither, rivers fall silent, and the air grows dusty. Yet the reasons for that silence often trace back to invisible patterns stretching thousands of kilometers. The atmosphere is a restless system, constantly adjusting to shifts in heat and pressure. Sometimes it favors abundance, and sometimes it withholds. The striking truth is that drought is rarely just bad luck. It is the product of order, an order so immense and intricate that it feels like chaos. The subtropical highs descend with precision, year after year. The Pacific breathes in its long rhythm of El Niño and La Niña. Blocking highs anchor themselves like invisible mountains in the sky, and beneath these vast orchestrations the land waits patiently, hoping for rain that may or may not come. This is why skies that withhold are as much a part of geography as mountains or rivers. They are features not of rock or soil, but of air and pressure, unseen yet deeply felt. A cloudless sky might look serene, but it can be the outward face of powerful forces at work, deciding whether the earth below will blossom or thirst. Dryness has many faces, and geography has given each of them a stage. Some landscapes are born dry, sculpted over millennia into deserts where rain is rare and life must cling to survival. Others are only part-time drylands, slipping into thirst during certain seasons or years before greening again when the skies remember their promise. To trace the geography of dryness is to wander from the most parched deserts to the edges of grasslands and steppes, comparing places where dryness is permanent with those where it is only a visitor. Take the Atacama Desert in northern Chile, often called the driest non-polar desert on Earth. Some weather stations there have never recorded rainfall in living memory, and in certain valleys the soil has gone centuries without a meaningful drop. This extraordinary dryness is not random. The Andes Mountains block moisture from the east, while the cool Humboldt Current chills the Pacific air to the west, preventing clouds from holding water. The Atacama sits in a double rain shadow, trapped between barriers that steal away every chance of precipitation. Yet, even here, life has found a way. Tiny lichen cling to rocks, and in rare years when moisture arrives, wildflowers paint the desert in brilliant colours, reminding everyone that even the most barren landscapes carry hidden potential. Contrast that with the Sahara, the world's largest hot desert, sprawling across much of North Africa. Unlike the Atacama, the Sahara does receive some rain, though often in short, violent bursts that vanish into flash floods rather than soaking into the ground. Its dryness is tied to the subtropical high-pressure system that dominates the region, keeping skies clear most of the year. The Sahara was not always so dry. Ancient rock art depicts hippos, giraffes and cattle wandering across what are now endless dunes, evidence of a greener past. Shifts in Earth's orbit altered monsoon patterns thousands of years ago, turning grasslands into desert. The Sahara is not simply a static wasteland, it is a record of climate change written in sand and stone. Further east, the Arabian desert stretches across the Arabian Peninsula. Its dryness is different again, shaped by continental location, subsiding air, and the influence of surrounding seas. While coastal oases provide pockets of water, the vast interior remains one of the harshest environments on the planet. Historically, nomadic groups adapted by moving constantly, following the delicate balance between scarce pasture and even scarcer wells. Dryness here is not only a natural condition but also a cultural force, shaping traditions of mobility, resourcefulness and resilience. Not all dry regions fit neatly into the category of desert. Semi-arid lands, such as steppes and savannas, live in a state of in-between. They are not barren, but their rainfall is too unreliable to support dense forests. Grasslands dominate, with scattered shrubs and trees surviving where roots can reach deeper water. The Eurasian steppe, stretching from Hungary through Central Asia, is a prime example. Its climate oscillates between extremes, bitterly cold winters and scorching summers, with rainfall that rarely arrives when it is most needed. Historically, these vast dry grasslands nurtured nomadic empires, from the Scythians to the Mongols, who mastered the art of living lightly on the land, following herds that could thrive in places unsuited to crops. The American Great Plains offer another variation. Once called the Great American Desert by early explorers, the region is better understood as a semi-arid prairie. Its rainfall is highly variable, with wet years producing lush grasses and dry years reducing the land to dust. This volatility became tragically clear during the Dust Bowl of the 1930s, when farming practices combined with drought to create storms that carried away millions of tons of topsoil. The Great Plains are not true desert, but their fragility shows how quickly semi-arid regions can tip into crisis when human use pushes beyond natural limits. Dryness is also seasonal in many parts of the world. The Sahel, lying south of the Sahara, is a band of semi-arid land where rains arrive only during a short monsoon season. A year of poor rains can devastate harvests, leaving communities vulnerable. Yet when the rains do come, the land springs to life. Fields of millet and sorghum growing quickly in the brief window before dryness returns. This oscillation defines life in the Sahel, where people adapt their crops, herds and traditions to rhythms of feast and famine. The distinction between permanent aridity and temporary drought becomes clear when comparing these regions. Deserts such as the Atacama or Sahara are dry because of long-standing geographic and climatic factors, high-pressure systems, cold ocean currents, or rain shadows. They are arid by design, and life there is built around scarcity. Semi-arid lands, by contrast, are not doomed to dryness year-round. Their challenge lies in variability. Rain might fall generously one year and scarcely at all the next, creating uncertainty that makes farming risky and survival precarious. Dryness also comes in surprising places. Parts of the Antarctic interior receive less precipitation than the Sahara, making them technically polar deserts. The McMurdo dry valleys, shielded by surrounding mountains, are so parched that their soil resembles the surface of Mars. Here, ice and snow seem to dominate, yet actual liquid water is almost absent. This highlights that deserts are defined not by heat, but by the lack of precipitation. Dryness wears many disguises. One fascinating aspect of permanent deserts is how clearly they map onto global circulation patterns. The bands of dryness at 30 degrees north and south reveal the precision of Earth's atmospheric engine. Semi-arid regions, meanwhile, exist in transition zones where these great patterns blur, creating instability. Geography shapes climate, but climate in turn shapes culture and ecology. Dry regions often foster resourcefulness, whether through nomadism, irrigation innovations, or resilient ecosystems of drought-tolerant plants. The geography of dryness is not a monotone story of absence, but a spectrum of conditions, from lands where rain is a myth to regions where rain is a gamble. It demonstrates how finely tuned Earth systems are, and how even small changes in circulation currents or human land use can shift the balance. Permanent deserts stand as monuments to stability and aridity, while semi-arid steppes and seasonal drylands remind us of the fragility of abundance. Ultimately, dryness is not a flaw in the planet's design, but a vital part of its diversity. Without deserts, there would be no unique species like the saguaro cactus or the oryx, no nomadic traditions shaped by scarcity, no stark beauty of dunes under starlight. Without semi-arid lands, there would be no vast steppes that carried horseborne empires, no savannas where grasses stretch as far as the eye can see. Dryness is one of geography's defining traits, a reminder that water, though plentiful on Earth, is not evenly shared. Some lands are destined to thirst, while others sip only occasionally, and that unevenness is what makes our world both challenging and endlessly fascinating. When thinking about drought, the first image that comes to mind is often an empty sky or a dry riverbed, but just as important is what happens beneath our feet. Soil, that unassuming layer of earth we walk across each day, plays a crucial role in deciding how a landscape responds to a lack of water. Its texture, its cover of vegetation, and the way people use it can mean the difference between resilience and disaster. The ground itself is either a quiet ally in times of dryness or a fragile surface that quickly gives way to dust. Soil is not just dirt. It is a living mixture of mineral particles, organic matter, air, and water. A good soil is like a sponge. It absorbs rainfall, holds moisture for roots, and releases it slowly during dry spells. Sandy soils with their large grains let water drain too quickly, while heavy clay soils cling to water so tightly that plants can struggle to extract it. The best soils for resisting drought are loamy blends, rich in humus and riddled with pores that both store and share water. It is this hidden architecture, invisible to most eyes, that dictates how long a landscape can endure without fresh rain. Vegetation adds another layer of resilience. Plants act as both umbrella and anchor. Leaves intercept raindrops, slowing their fall and reducing the force that can erode the soil. Roots burrow deep, binding particles together and carving channels that improve infiltration. A grassland thick with roots can soak up and hold water far better than bare ground. Forests, with their canopy and leaf litter, are even more effective, creating a natural system of water storage. Strip the vegetation away, however, and soil is left naked under the sun, quick to dry and easy to blow away. This vulnerability is at the heart of dust storms. When dry soil is loose and unprotected, winds lift it into the air, carrying it for hundreds or even thousands of kilometers. The result can be dramatic walls of dust, sometimes kilometers high, rolling across the horizon. In the 1930s, the American Great Plains saw such storms on an epic scale during the Dust Bowl. Poor farming practices left soil bare and powdery, and when drought arrived, winds carried topsoil into the sky. Families would seal their windows and still find fine dust coating their furniture. Entire farms were abandoned as the land lost its ability to support crops. What began as a problem of rain became a catastrophe of soil. Dust storms are not confined to history. Parts of China, the Middle East, and northern Africa still experience them today, often worsened by overgrazing, deforestation, and intensive agriculture. When vegetation is stripped away faster than it can recover, soils degrade and deserts expand. This process is called desertification, a word that carries an air of finality. Desertification does not mean sand dunes suddenly appear overnight, but rather that productive land slowly loses its fertility, turning into dry, barren ground that can no longer sustain crops or pasture. The Sahel region of Africa has long been a textbook case. Stretching across the southern edge of the Sahara, the Sahel is prone to variable rainfall. Periods of drought in the late 20th century combined with pressures from growing populations and grazing animals to accelerate soil degradation. Grasslands thinned, soils became crusted and hard, and dust storms became more frequent. Efforts to combat desertification have since included planting green belts of trees and adopting more sustainable land use, a reminder that human choices can either worsen or help heal the land. Soil degradation takes many forms, from the gradual loss of organic matter to the erosion of entire layers by wind and water. Overploughing can break down soil structure, reducing its ability to hold water. Irrigation, while solving water shortages in the short term, can leave behind salts that poison the soil. Mining and construction scrape away fertile topsoil, leaving behind surfaces that cannot easily recover. Each of these processes increases vulnerability to drought, turning what could have been a temporary dry spell into long-term decline. The relationship between soil and drought is cyclical. Dry conditions weaken vegetation, leaving more ground exposed. Exposed soil erodes, degrading fertility. Poor soils hold less water, making crops weaker in the next dry spell. This downward spiral can lock communities into patterns of scarcity. Breaking the cycle requires not just waiting for rain, but actively restoring the soil's capacity to absorb and store it. Practices such as crop rotation, cover cropping, and reduced tillage can rebuild organic matter. Terracing slopes can slow runoff, while planting windbreaks can reduce erosion. These are simple interventions, but they make a remarkable difference in how landscapes face dryness. At the same time, soils are not only victims in this story, they can also be saviours. Healthy soils act like reservoirs, storing vast quantities of water beneath the surface. A hectare of rich organic soil can hold thousands of litres, slowly releasing it to crops and groundwater systems. When people talk about green water, they mean this hidden reserve locked in soils and vegetation, as important as rivers and reservoirs. In this sense, investing in soil health is a form of drought preparedness as vital as building dams or digging wells. The influence of soils extends even to the atmosphere. Dust storms can carry particles high into the sky, affecting cloud formation and even altering climate patterns. Fine dust blown from the Sahara fertilizes the Amazon rainforest across the Atlantic with vital nutrients like phosphorus. Soil in motion becomes part of a planetary cycle, its effects felt far from the place where it first lifted into the wind. It is striking to consider how something as ordinary as soil, trodden on daily without thought, can determine whether a community weathers drought or collapses under it. Beneath the surface lies a fragile architecture of pores, roots, and microbes that, when intact, forms a buffer against scarcity. Disturb it, and that buffer crumbles, leaving only dust and thirst. Dry ground is not just a symptom of drought, it is a participant. When soil is healthy and clothed in vegetation, it absorbs shocks, stores resources, and recovers with the rains. When it is degraded, each dry spell becomes a deeper wound. The geography of dryness, then, is not only mapped in deserts and rainfall charts, but also in the quality of the earth itself, one handful of soil at a time. Rivers are often thought of as eternal. They carve valleys, shape borders, and sustain cities, and the idea that one could simply vanish feels almost impossible. Yet rivers are not permanent fixtures. Some disappear for part of each year as seasons change, while others shrink dramatically during times of drought. A few, once mighty and famous, now fail to reach the sea at all. These vanishing rivers remind us that watercourses are not fixed threads, but fragile lifelines, vulnerable to the rhythms of climate and the demands of human society. The Colorado River is perhaps the most famous example of a modern river under strain. Rising in the snowy peaks of the Rocky Mountains, it once flowed all the way to the Gulf of California, nourishing wetlands and communities along its way. Today the river is so heavily dammed, diverted and extracted that it rarely completes its journey to the sea. Its waters are siphoned off to supply sprawling cities like Las Vegas, Phoenix and Los Angeles, and to irrigate vast agricultural fields in the desert southwest. Add prolonged drought in the region, and the result is a river that sometimes ends in dry sand long before it reaches the ocean. For those living in the basin, the Colorado is both a triumph of engineering and a warning of limits. It illustrates how a river can appear permanent yet be pushed to the edge of disappearance. Across the world in China, the Yellow River has an equally dramatic story. Known as the Mother River of Chinese civilization, it has supported agriculture and cities for thousands of years. But the Yellow River is also infamous for running dry. In the 1990s, the river failed to reach the Bohai Sea for more than 200 days in a row, leaving its lower channel empty. Overuse of water for irrigation, combined with variable rainfall, meant that the river's flow was exhausted long before reaching the coast. Since then, water management reforms have improved the situation somewhat, but the memory remains sharp. Even a river that has carried empires on its back can be reduced to dust if demand exceeds supply. Seasonal disappearance is a natural part of many rivers. The Limpopo in southern Africa, for example, often dwindles to a string of pools during the dry season, only to swell again when rains return. This rhythm has shaped the cultures and ecosystems along its banks. Farmers plant crops timed to the floods, and wildlife moves with the water. In India, ephemeral rivers known as nullas fill during the monsoon and vanish during the dry months, their sandy beds becoming roads and gathering places until the rains reclaim them. For communities here, a vanishing river is not a crisis but a cycle, a predictable pattern around which life is organised. Other rivers vanish in ways that are more troubling. The Rio Grande, which forms part of the border between the United States and Mexico, has in some stretches dwindled so severely that it can be crossed on foot. Demand for irrigation and urban supply competes with changing rainfall patterns, leaving stretches of the channel parched. In Australia, the Murray-Darling Basin faces similar pressures. During extended droughts, tributaries contract into shallow pools, threatening both farming communities and the ecosystems that depend on the flow. These cases highlight how human use and climate stress can combine to silence rivers that once seemed reliable. Not all rivers vanish completely, but many experience reduced or altered flows that reshape entire landscapes. The Nile, one of the world's most iconic rivers, depends heavily on rainfall thousands of kilometers away in the Ethiopian highlands. When drought strikes that region, the lower Nile feels the impact. In antiquity, the failure of the Nile floods could bring famine to Egypt, since the annual inundation was the heartbeat of agriculture. Today, with dams and diversions regulating its flow, the river does not vanish, but the delicate balance of supply remains a concern. The Nile story shows how even great rivers have always been tied to distant skies. The disappearance of rivers affects more than human settlements. Ecosystems unravel when flows vanish. Fish that once migrated freely find their pathways blocked or dried. Wetlands that filtered water and provided habitat shrink into cracked mud. Birds lose resting places on their journeys, and crops dependent on irrigation wither. The vanishing of a river is not just a local inconvenience, it is the silencing of an entire web of life. Dust and salt often creep into the void left behind. When rivers no longer reach the sea, deltas retreat, and salt water intrudes inland. The Colorado Delta, once a lush maze of wetlands, is now largely dry and saline. In China, the Yellow River's reduced flow has allowed coastal erosion to eat away at land. These secondary effects reveal how rivers shape landscapes far beyond their visible channels, and how their disappearance can ripple outward in unexpected ways. Climate change adds yet another layer of tension. Warmer temperatures increase evaporation, snowpacks melt earlier, and rainfall patterns become less predictable. Rivers that relied on gradual snowmelt, such as many in the American West, now experience earlier surges and longer late summer dry spells. In mountainous regions from the Andes to the Himalayas, shrinking glaciers threaten to reduce the long-term water supply for rivers that feed millions of people. What vanishes is not just a river's flow, but the certainty that it will always return. And yet, rivers have a remarkable ability to surprise. In years of heavy rain, even long dry channels can roar back to life. The once vanished Colorado Delta has seen experimental restoration, with carefully released water pulses reviving wetlands and bringing birds back to the region. Communities along ephemeral rivers celebrate their brief return each rainy season, treating the flowing water as both necessity and festival. These moments show that vanishing rivers are not only stories of loss, but also of renewal when conditions allow. The truth is that no river is truly permanent. Each one is a moving thread of the water cycle, dependent on rainfall, snowmelt, groundwater, and the choices people make. Some vanish predictably with the seasons, others falter under human pressure, and still others disappear when skies withhold their rain for too long. To follow a river is to follow a promise, one that can be broken when conditions shift. When rivers vanish, they leave more than dry beds. They leave questions about how societies balance their needs with nature's limits, about how ecosystems endure absence, and about what resilience looks like when the flow that shaped a land falters. These questions linger like the memory of water in cracked soil, reminding us that even the strongest currents are only temporary guests in the landscapes they carve. Drought feels immediate when it arrives. Empty skies, cracked soils, dry wells. Yet the story of drought is not only about the present. The earth itself holds memories of ancient dry spells, records etched in sediments, tree rings, and even the chemistry of cave formations. These natural archives stretch back centuries, even millennia, allowing scientists to see beyond modern weather reports into a deep history of scarcity and change. To understand today's droughts, and the ones that may come, it helps to listen to what the planet has quietly written down. One of the most vivid record keepers is the Humble Lake. Sediments settling on the bottom of lakes build up in layers, year after year. When times are wet, those layers are thick and rich with organic material. When dry years arrive, the deposits change, thinner, dustier, sometimes carrying the marks of wind-blown sand. By extracting long cores from lake beds, scientists can read these annual bands like pages in a book. In East Africa, cores taken from Lake Turkana and Lake Malawi have revealed epic swings in rainfall, stretching back hundreds of thousands of years. These ancient droughts shaped not only landscapes, but also the evolutionary path of humanity itself, influencing when and where early hominins could thrive. Tree rings offer another elegant archive. Each year a tree grows, it adds a new ring, wide when conditions are good and narrow when water is scarce. By examining these rings, dendrochronologists can reconstruct centuries of climate variation. In the American Southwest, tree ring records have uncovered evidence of mega droughts, dry periods lasting not just a few years but several decades. These extended droughts were far more severe than anything recorded since European settlement, showing that the natural climate has long carried extremes that dwarf our recent experiences. For the ancestral Puebloan people, who built cliff dwellings at places like Mesa Verde, such mega droughts may have played a role in the eventual abandonment of their settlements. Caves too hold their secrets. Stalactites and stalagmites grow slowly as water drips through the ground, carrying minerals that build up over thousands of years. The chemistry of these formations shifts with the amount of water passing through. By analysing oxygen isotopes in cave deposits, researchers can reconstruct patterns of rainfall stretching back deep into prehistory. In China, cave records have revealed links between drought and the weakening of dynasties. Periods when monsoons faltered often coincided with times of social unrest, suggesting that the pulse of rain from distant skies could shake even the strongest empires. Even the oceans carry the imprint of past droughts. Corals, like trees, lay down growth bands that vary with environmental conditions. Their skeletons capture changes in sea surface temperature and salinity, both of which influence rainfall over nearby lands. By drilling tiny cores into corals, scientists can reconstruct centuries of El Niño and La Niña cycles, uncovering the oceanic rhythms that have long driven drought and deluge across continents. These methods do not simply reveal when droughts happened, but also their scale and persistence. In North America, paleoclimate evidence shows that the so-called Dust Bowl of the 1930s was relatively modest compared to mega-droughts that struck centuries earlier. Some of those earlier dry spells lasted 50 years or more, a sobering reminder that nature is capable of far harsher trials than the modern era has yet seen. Similarly, in the Middle East, sediment cores from the Dead Sea reveal cycles of intense drought stretching back tens of thousands of years, far beyond the reach of written history. These records are invaluable because written chronicles are relatively young. Most civilizations could only document climate for a few thousand years at most, and often their accounts are fragmentary. Mentions of famine, inscriptions of prayers for rain. Natural archives stretch far further, filling in the blanks with physical evidence. By combining multiple lines of evidence, tree rings, sediments, ice cores, cave deposits, scientists build a more complete picture of the Earth's shifting water balance. What emerges is a story not of stability but of variability. Droughts are not anomalies, they are part of a natural rhythm. The alternating wet and dry phases of climate have shaped where people settled, how societies rose and fell, and how ecosystems evolved resilience. Grasslands in Africa, for example, are adapted to cycles of plenty and scarcity, with animals migrating long distances in search of greener pastures. Human cultures too learn to adapt, storing grain in good years, digging wells, or moving herds to follow rain. The deep time perspective also carries warnings. If mega droughts occurred naturally in the past, then in a world now warmed by human influence, their likelihood may increase. Modern infrastructure, from reservoirs to mega-cities, is built on the assumption that water supplies will fluctuate within certain bounds, but paleoclimate evidence suggests those bounds may be too narrow. A drought lasting several decades could test systems far beyond their limits. There is something humbling in realizing that the cracked soils of today echo patterns laid down thousands of years ago. Each tree ring, each layer of lake mud, each crystal in a cave is a witness to the patience of the earth, quietly recording while civilizations come and go. These records remind us that drought is not a new challenge, but a recurring companion in human history. And there is beauty in these archives too. A polished stalagmite glowing under a researcher's lamp, a slim core of layered sediments revealing centuries in a column no wider than a hand, a tree trunk sliced to reveal its secret calendar. They're all quiet storytellers. Their language is not words but patterns of growth and absence, swelling and narrowing, thick layers and thin. To learn from them is to hear the earth speaking in slow time. The memory of drought, then, is not just written in human stories of hardship, but also in the patient records of nature itself. By reading those stories, we see that dryness is not an occasional accident, but a constant force shaping life on Earth. And if the past is any guide, the skies of the future will not always be generous. The Earth has withstood long thirst before, and it will again. The question is how well we will remember its lessons. Civilizations often appear in history books as though they were permanent fixtures. Great cities, powerful rulers, and flourishing cultures that seemed destined to endure. Yet time and again, societies that looked unshakable crumbled. leaving behind ruins, legends, and unanswered questions. Among the many forces that toppled them, drought played a subtle but devastating role. It rarely swept in like a conquering army. Instead, it crept into daily life, draining reservoirs, thinning harvests, and fraying the bonds that held communities together. When skies withheld rain, entire empires sometimes fell silent. One of the most famous examples is the Maya civilization, which reached its height in Central America between roughly the 3rd and 9th centuries. The Maya built magnificent cities, carved intricate glyphs, and developed an advanced calendar. Their society stretched across what is now Mexico, Guatemala, Belize, and Honduras. Yet by the end of the 9th century, many of their great urban centres were abandoned. Archaeologists long puzzled over why such a sophisticated culture declined. In recent decades, evidence has pointed strongly to drought. Lake sediment cores from the Yucatan Peninsula reveal repeated dry periods around the time of the Maya collapse. Chemical signatures show that rainfall decreased by as much as 50% during crucial decades. Without reliable rain, the reservoirs and limestone cisterns the Maya depended on began to fail. Crop yields plummeted, and populations that once thrived in densely packed cities could no longer be supported. The collapse was not instantaneous. It unfolded over generations. But the thread linking dwindling water to political instability and urban abandonment is clear. A society built on the cycles of rain was undone when those cycles faltered. Centuries earlier, drought had already left its mark in Mesopotamia. The Akkadian Empire, which emerged around the 24th century BCE, is often described as the world's first true empire. It united city-states under a central ruler, stretching from the Persian Gulf deep into the Levant. Yet its dominance was surprisingly short-lived, collapsing within about a century. Archaeological evidence and climate data suggest that prolonged drought played a decisive role. Dust deposits from across the Middle East indicate that around 4,200 years ago, a major dry spell swept through the region. Rivers shrank, agriculture faltered, and nomadic groups pressed into settled lands. Written records from the time speak of famine and social turmoil. The Akkadian state, stretched across arid lands dependent on irrigation, proved vulnerable. Without consistent water, its agricultural base weakened and the empire unravelled. This 4.2 kilo-year event, as scientists now call it, marks a turning point not just for Akkad but for civilizations across the Old World, showing how widespread climate stress could ripple across multiple regions at once. Other societies have similar stories. In the American Southwest, the ancestral Puebloans built impressive cliff dwellings and irrigation systems, their communities thriving for centuries. Yet during the late 13th century, a series of mega-droughts struck the region. Tree ring records show decades of aridity, some of the harshest dry spells in the last 1,000 years. Crops failed, and populations dispersed from sites like Mesa Verde and Chaco Canyon. The stone cities remain as silent witnesses to a society forced to scatter when water disappeared. In South Asia, the decline of the Indus Valley civilization around 1900 BCE has also been linked to changing water supplies. This Bronze Age society created carefully planned cities like Mohenjo-daro and Harappa, complete with sophisticated drainage systems. But studies of river sediment suggest that shifts in monsoon rains weakened the mighty Saraswati and Indus rivers that sustained agriculture. With unreliable water, urban life grew harder to maintain. Populations gradually moved eastward toward areas with stronger monsoons, leaving behind the empty grid-like streets of once thriving cities. Even in ancient Egypt, whose history is often portrayed as a seamless line of dynasties, drought left scars. Nile floods were the pulse of Egyptian life, depositing fertile silt and ensuring harvests. But when those floods failed, famine followed. Inscriptions from the First Intermediate Period, roughly 4,000 years ago, describe widespread hunger and social disorder, linked to low Nile floods. Though Egypt recovered, the episodes revealed how even the most river-blessed civilization could stumble when the sky withheld rain upstream. The pattern repeats across continents. The Khmer Empire of Cambodia, centered on the majestic temples of Angkor, flourished for centuries thanks in part to an elaborate water management system of canals and reservoirs. Yet in the 14th and 15th centuries, the region experienced alternating cycles of drought and heavy monsoon rains. The infrastructure, once a marvel of hydraulic engineering, proved unable to handle such extremes. Reservoirs dried, then canals burst under sudden floods. The breakdown of this system coincided with the decline of Angkor, showing how climate instability could unravel even highly adapted societies. What is striking in all these stories is that drought rarely acted alone. It was not just the absence of rain, but the combination of environmental stress with political fragility, population pressure, and sometimes conflict. When water grew scarce, rulers lost legitimacy, trade routes shifted, and people sought new homes. Drought exposed weaknesses already present, amplifying them until they became unmanageable. It was both a trigger and a magnifying glass. For those who lived through these collapses, the experience must have been bewildering. Imagine being a farmer in a Maya city, watching reservoirs shrink year after year, or a scribe in Akkad recording the arrival of dust storms that turned the skies dark. The sense of helplessness, the prayers for rain that went unanswered, and the gradual realization that the society around you was unraveling. These were deeply human experiences, not just abstract events in a timeline. Looking back, the ruins of these civilizations remind us that water is as vital to empires as walls or armies. Cities can withstand invasions and rebuild after earthquakes, but prolonged drought undermines the very basis of survival. Fields empty, granaries hollow, and eventually people move on, leaving behind stone monuments that whisper of vanished abundance. The silence of these fallen civilizations is not only a cautionary tale, but also a reminder of resilience. People did not vanish entirely. They adapted, migrated, and carried their knowledge elsewhere. The descendants of the Maya, the Akkadians, the Puebloans, and others still live on. Their cultures transformed but not erased. Drought tested them, reshaped them, and in some cases scattered them, but humanity endured. History, then, is full of dry echoes, moments when the skies closed and societies faltered. They teach us that civilizations are not undone overnight, but eroded gradually, like rivers in drought shrinking to a trickle before disappearing. And they remind us, too, that the bond between water and society is ancient and unbreakable, even if the form of that bond changes with each generation. Life in the desert is often imagined as impossible, a place where the sun beats mercilessly and the earth offers nothing in return. Yet for millennia, people have not only survived in these landscapes, but have built cultures, traditions, and ways of life uniquely tuned to scarcity. Desert societies are living proof that human ingenuity thrives even where nature seems least generous. Their survival has depended on one unchanging truth: water is precious, and every drop must be valued. The most basic strategy was finding water where it hides. Wells have been the lifeblood of desert communities across the world. In the Sahara, ancient peoples dug deep shafts to tap into underground aquifers, creating life-giving sources in otherwise barren terrain. Some of these wells, maintained for centuries, became centres of trade and settlement, with caravans planning their routes from one to the next. In Arabia, a similar tradition of hand-dug wells sustained nomadic herders and traders, each community carefully guarding its knowledge of hidden water sources. To stumble across an unexpected well in the desert was like finding treasure. Not all water was underground. Oases offered green havens where groundwater reached the surface, forming natural springs or shallow lakes. Around these rare spots, palm groves grew, crops could be planted, and settlements flourished. The oasis was more than a physical refuge. It was a cultural and social one too. In North Africa, entire towns rose around oases, their date palms providing food, shade, and income. The palm itself became a symbol of life in the desert, a vertical testament to survival against the odds. To use water wisely required innovation. In Persia, engineers developed qanats, underground channels that carried water from mountains to lowland farms. These gently sloping tunnels could stretch for kilometers, protected from evaporation by being buried beneath the ground. The system was so effective that many qanats are still in use today, supplying villages with steady water in climates where surface streams would vanish in hours. Similarly, in North Africa, foggarras, networks of subterranean galleries, perform the same task, silently moving water beneath the earth. These feats of engineering show that desert societies did not passively endure dryness, but actively reshaped their environments to live within it. In desert climates, storage mattered as much as supply. Rain, rare though it was, could be captured and saved. Cisterns carved into rock collected runoff, ready to be tapped during long dry spells. In the Negev desert of Israel, ancient communities built intricate systems of channels and reservoirs to catch flash floods. What seemed like destructive torrents became seasonal gifts, carefully harnessed to irrigate fields and sustain settlements. These systems were so well adapted that some can still be traced today, silent testimony to resilience. Nomadic traditions brought a different kind of adaptation. For groups like the Bedouin in Arabia or the Tuareg in the Sahara, survival meant movement. Instead of trying to force the land to yield, they followed the shifting resources. Camels, famously called ships of the desert, were indispensable companions, able to go days without water and carry supplies across vast distances. Tents made of woven goat hair provided shelter that was both portable and breathable, cooling by day and warming by night. Knowledge of routes, seasons, and the behaviour of animals was passed down orally, a cultural map of survival etched in memory rather than on paper. Food practices also reflected scarcity. Dates, milk, and grains became staples because they could be stored and carried. In some regions, milk was dried into cheese or butter that lasted long journeys. Salt, mined from desert deposits, preserved meat, and served as a valuable trade item. Nothing was wasted. Frugality became an art. To live in the desert was to live with constant awareness of limits, and culture grew around making the most of little. Desert survival was not only physical but also spiritual. Many desert societies developed cultural practices and beliefs centered on water. Wells were often considered sacred, protected by rituals that emphasized their importance. In Islamic tradition, the story of Hagar finding the Zamzam spring in Mecca is one of divine intervention in a desert, and the spring itself continues to flow today, drawing millions of pilgrims. Among nomads, poems and songs celebrated rain, not as a casual occurrence but as a miraculous renewal. This reverence reinforced the idea that water must never be taken for granted. Trade routes through deserts relied on these adaptations. Caravans crossed the Sahara carrying gold, salt and spices, navigating by stars and stopping at oases spaced like stepping stones. Without the ability to find or store water, such commerce would have been unthinkable. The Silk Road itself crossed arid stretches of Central Asia, supported by wells and caravanserais where weary travellers could rest. Dryness did not isolate these regions, it forced ingenuity that connected distant corners of the world. Even architecture bore the imprint of adaptation. Thick walls and small windows kept desert homes cool, while wind towers in Persia captured breezes and funneled them indoors. Courtyards with fountains or shaded pools moderated temperature, creating microclimates in otherwise harsh surroundings. These designs were not luxuries but practical responses to the reality of heat and aridity. They illustrate how culture and climate are woven tightly together. Desert survival also meant knowing how to read the land. Nomadic herders learned to track the presence of water by observing vegetation, animal movements, or even subtle changes in the colour of soil. Indigenous groups in Australia developed deep knowledge of soakages, hidden water holes in sandy landscapes, remembered and passed down through songlines. These traditions acted as living maps, guiding communities across terrains that might appear empty to outsiders. What ties all these strategies together is adaptability. Desert peoples did not fight dryness. They worked with it, bending their lives to its rhythm. They knew that rain could not be controlled, but knowledge, mobility, and careful management could make survival not only possible but sustainable. In doing so, they created cultures of resilience that continue to inspire today. It is easy to look at a desert and see only hardship, yet beneath the scorching sun and shifting dunes lies a long history of human determination. Wells and oases, qanats and cisterns, nomads and caravans. Each is a reminder that survival in the desert is not about conquest, but about harmony with scarcity. These practices transformed hostile landscapes into homes, proving that with ingenuity and respect for resources, even the driest lands can sustain life. The story of the Dust Bowl is one of the most vivid examples of what happens when human ambition collides with the stubbornness of nature. In the 1930s, vast stretches of the American Great Plains were transformed from productive farmland into a landscape of dust storms, failed crops, and abandoned homesteads. It was a disaster born not from drought alone, but from the combination of dry skies, fragile soils, and farming practices that pushed the land beyond its limits. The Dust Bowl became a powerful lesson in how closely human fortunes are tied to the environment, and how quickly those fortunes can change. The Great Plains had long been viewed with a certain suspicion by early settlers. In the 19th century, explorers described it as the Great American Desert, a region too dry for farming. But with new railroads, the promise of land, and the invention of steel ploughs that could break tough prairie sod, settlers began to move in. Encouraged by government policies like the Homestead Act, thousands of families carved fields into the grasslands, planting wheat as the crop of choice. At first, the gamble seemed to work. During the 1920s, several years of good rainfall coincided with high demand for wheat. Farmers ploughed deeper and planted more, removing millions of acres of native prairie grasses. These grasses had evolved over millennia to withstand drought and hold soil in place with their extensive root systems. Once uprooted, the soil lay exposed and vulnerable. The fields produced bountiful harvests in the short term, but the stage was set for disaster when the rain stopped. And stop they did. In the early 1930s, the Great Plains experienced a severe and prolonged drought. The skies withheld rain, the ground cracked, and crops failed. Without the stabilizing presence of native grasses, the soil quickly dried out and turned to powder. When strong winds swept across the plains, they carried the topsoil away in enormous clouds. These black blizzards, as they were called, could blot out the sun for hours, turning midday into a strange, choking twilight. Dust crept into homes despite every effort to seal doors and windows. Families would wake to find their beds covered in a fine layer of grit, lungs and eyes irritated by particles carried on the wind. The scale of the storms was almost unbelievable. Some dust clouds rose thousands of feet into the sky and stretched hundreds of miles. One famous storm in 1935, known as Black Sunday, carried so much dust that it reached the East Coast, darkening skies in cities like Washington, D.C. and New York. Farmers in the plains might have felt their plight was local, but the dust made sure the whole nation saw their struggle. The Dust Bowl was not caused by drought alone. Drought was the spark, but poor land management was the fuel. By ploughing under the prairie grasses and farming intensively without practices to conserve soil, settlers had unknowingly created conditions ripe for erosion. Wheat farming on such a vast scale proved brittle in the face of climate variability. When the market for wheat collapsed during the Great Depression, farmers had even less capacity to cope. It was a perfect storm of economics, environment, and weather. For those who lived through it, the human toll was immense. Crops failed year after year, Livestock starved, and families were forced to abandon their farms. Many packed what they could onto trucks or wagons and headed west in search of better prospects. California became a destination for thousands of Dust Bowl migrants, often called Okies, regardless of whether they actually came from Oklahoma. Their struggles were immortalized in literature, such as John Steinbeck's The Grapes of Wrath, which captured both the hardship and the resilience of these displaced families. Health was another hidden cost. Dust pneumonia became a grim reality as people inhaled fine particles that damaged their lungs. Doctors reported children suffocating when dust storms blew through. The psychological burden was also heavy. Imagine planting season after season, only to watch fields fail again and again, the wind undoing in minutes what took months of labour. It was not only livelihoods, but a sense of hope that dried up. The disaster eventually spurred change. In response, the United States government created programs to promote soil conservation and sustainable farming. The Soil Conservation Service, founded in 1935, encouraged practices such as contour ploughing, crop rotation, and planting windbreaks of trees. Farmers learned to leave stubble on fields to reduce erosion and to restore some of the natural grasses that had once protected the land. These measures did not end the drought. Only rain could do that. But they reduced the damage and laid the groundwork for more resilient agriculture. When rains finally returned at the end of the decade, the Dust Bowl slowly eased, but the memory of those years lingered, etched into both the land and the culture. It demonstrated that humans are not separate from natural systems, but deeply entwined with them. It also showed that prosperity built on fragile foundations can collapse with startling speed when climate variability is ignored. The Dust Bowl has since become a symbol of caution in discussions about climate, land use and resilience. Modern farming techniques and irrigation have transformed the Great Plains into a productive agricultural region once again, but the balance remains delicate. Water from the Ogallala Aquifer, a key resource for irrigation, is being depleted faster than it can be replenished. Scientists warn that another prolonged drought could still bring serious consequences. The lessons of the 1930s remain painfully relevant. Looking back, the Dust Bowl is not just a tale of dust storms and hardship. It is also a story of human adaptability. Out of the crisis came a greater awareness of the need to respect natural systems, to farm with the land rather than against it. It was a harsh teacher, but its lessons have rippled far beyond the Great Plains. The sight of a black blizzard rolling over the horizon must have felt apocalyptic to those who witnessed it. Yet even in that darkness, people endured. They rebuilt, learned, and carried forward knowledge that would help future generations. The Dust Bowl was a catastrophe, but it was also a turning point. Proof that even in the face of the worst that drought and dust could deliver, resilience was still possible. In the 21st century, drought is no longer a challenge faced only by scattered villages or farming communities. Today, it presses against the walls of megacities, tests the capacity of modern infrastructure, and rattles the confidence of economies built on the assumption that water will always flow when the tap is turned. The world's great urban centres and sprawling agricultural systems are finding that their sheer scale makes them both powerful and precarious in the face of water scarcity. Cape Town, South Africa, became a striking symbol of this new reality in the late 2010s, when the city confronted what was ominously called Day Zero. After several consecutive years of poor rainfall, the reservoirs that supplied the city's nearly 4 million residents dropped to critically low levels. Officials calculated the date when water would no longer be available through the normal distribution system, the day when taps would run dry and people would have to queue at emergency points for their daily ration. For a modern metropolis, this was almost unthinkable, more the plot of a dystopian novel than the reality of daily governance. The crisis forced extraordinary measures. Strict restrictions were placed on water use, limiting households to as little as 50 litres per person per day, enough for essential drinking, cooking and a very quick shower, but far from the luxury of long baths or lush green lawns. Campaigns encouraged citizens to capture grey water from sinks and showers for reuse. Hotels removed plugs from bathtubs, and signs reminded guests to keep showers under 2 minutes. Some households even resorted to keeping buckets in the bathroom to catch every stray drop. What was remarkable, however, was the city's collective response. Consumption plummeted as people adapted, and the dreaded day zero was repeatedly pushed back until rains eventually arrived to replenish the dams. Cape Town had skirted the edge of the unimaginable, but the memory remains a warning for cities worldwide. Even the modern world is not immune to running out of water. On the other side of the planet, California has been grappling with its own persistent struggles with drought. The state's Mediterranean climate, with its wet winters and long dry summers, has always made water management a delicate balancing act. Add in a booming population, thirsty crops like almonds and rice, and the unpredictability of climate change, and the situation becomes even more complex. Reservoirs like Lake Oroville and Shasta Lake can swing dramatically from full to parched within a few years, depending on snowpack in the Sierra Nevada. California's Central Valley, one of the most productive agricultural regions in the world, is particularly vulnerable. Fields of fruit, nuts, and vegetables that feed not only the United States but also global markets rely heavily on irrigation. During drought years, when surface water allocations shrink, farmers increasingly turn to groundwater. But this has led to alarming declines in aquifer levels, with some areas experiencing land subsidence as the ground sinks where water has been withdrawn. The long-term concern is that these underground reserves, once depleted, cannot easily recover. In effect, the state is spending its savings account of water faster than it can be replenished. Urban areas in California also face challenges. Los Angeles, for example, imports much of its water from distant sources like the Colorado River and the Owens Valley. Prolonged drought strains these supply lines, creating tension between cities, farmers, and neighbouring states that share the same rivers. Water restrictions during the worst drought years became part of daily life. Lawns went brown, car washing was banned, and a new aesthetic of drought-tolerant landscaping emerged, swapping thirsty grass for gravel, cacti, and succulents. These examples show how modern societies adapt, but also how vulnerable they remain. Megacities have tools that ancient civilizations lacked: desalination plants that can turn seawater into drinking water, recycling systems that purify wastewater for reuse, satellite monitoring that tracks snowpack and reservoir levels. Yet these innovations are not silver bullets. Desalination, while effective, is energy-intensive and expensive. Recycling requires sophisticated infrastructure and public acceptance. Technology can buy time, but it cannot conjure rain. The global picture is sobering. Cities from Sao Paulo to Chennai have faced severe water shortages in recent decades, each time sparking the same realization. No matter how advanced a society may be, it is ultimately tethered to rainfall, rivers, and aquifers. In Sao Paulo in 2014, reservoirs dropped so low that officials used what they called dead water, the dregs below the normal intake pipes. In Chennai in 2019, all 4 of the city's reservoirs ran dry, forcing water to be trucked in. These crises underscore how close the margins can be in a world where climate change is shifting rainfall patterns and increasing evaporation. Agriculture adds another layer of complexity. Globally, about 70% of all freshwater withdrawals go to farming. This means that when drought hits, food security quickly becomes part of the equation. Countries reliant on irrigation face hard choices: prioritize water for crops, cities, or industry. In some cases, this has led to tension between regions and even across national borders. The Colorado River, for example, is shared by 7 US states and Mexico, with each stakeholder watching nervously as flows decline. Yet the story is not only one of crisis. Cape Town's near miss demonstrated how collective action can dramatically reduce water use. California has invested heavily in groundwater management and efficiency technologies such as drip irrigation to stretch limited supplies. Innovations in data collection now allow farmers to measure soil moisture with precision, applying just enough water to keep crops alive without waste. These efforts reflect a shift in thinking. Water is not an unlimited resource, but one that must be actively managed, conserved, and respected. The human dimension is also worth noting. Water scarcity in the 21st century is not just about taps and fields, but about inequality. Wealthy households or companies may afford private wells, bottled water, or advanced filtration systems, while poorer communities face shortages most directly. In some rural parts of California, residents rely on deliveries of drinking water when local wells run dry. In South Africa, townships bore the brunt of restrictions during Cape Town's crisis. Drought exposes fault lines in societies, highlighting who has access to resilience and who does not. The 21st century, then, is witnessing a paradox. Never before have humans had so much technological capacity to manage water, yet never has the challenge of drought felt so pressing. Climate change, growing populations, and expanding agriculture mean that more people than ever live close to the edge of scarcity. Each modern drought carries echoes of the past. The silence of ancient wells, the collapse of fields in forgotten empires, but with the added complexity of mega-cities, global trade, and billions of lives dependent on fragile systems. When people in Cape Town queued at public taps, or when Californians saw bathtub rings around shrinking reservoirs, they were living reminders that drought is not a distant or ancient threat. It is here, it is modern, and it is shaping the choices of our time. The question facing the 21st century is not whether drought will come, it will, but how societies will prepare, share, and adapt when the skies grow silent once again. When drought lingers, it is not only people who feel the strain. Entire ecosystems, forests, grasslands, wetlands, and the creatures that call them home are forced into survival mode. Some bend and adapt, finding clever ways to endure. Others break, collapsing when the long wait for water stretches too far. Drought is as much a test of resilience for nature as it is for human societies, and the responses are as varied as the landscapes themselves. Plants are the first to show the signs of stress. Leaves wilt, growth slows, and flowers fail to bloom. Yet many species have evolved remarkable strategies to cope with scarcity. Some desert plants, like cacti and succulents, store water in thick, fleshy tissues, rationing it drop by drop. Others, such as the creosote bush of the American Southwest, spread wide networks of roots to capture every trace of moisture. Grasses often adopt a different tactic altogether. They retreat. When conditions become too harsh, many grasses wither above ground, leaving behind seeds or dormant roots that wait patiently for the rains to return. To the untrained eye, a drought-stricken field may look lifeless, but hidden just below the surface, life bides its time. Forests, however, face greater challenges. Trees cannot simply pick up and move to wetter ground. In prolonged drought, they close their stomata, tiny pores on leaves, to conserve water, but this also slows photosynthesis. Growth falters, branches weaken, and trees become vulnerable to pests. Bark beetles, for instance, thrive when trees are weakened, their infestations spreading rapidly during dry years. In the Amazon, even the mighty rainforest shows signs of stress when drought reduces river levels and dries soils. The lush canopy loses leaves, carbon uptake decreases, and in some extreme cases patches of forest die back. Though rainforests are often seen as inexhaustible green machines, their resilience has limits. Wetlands are perhaps the ecosystems most visibly altered by drought. These environments depend on consistent water, and when inflows stop, marshes and swamps can shrink into cracked mudflats. Fish populations decline, bird migration routes are disrupted, and amphibians lose critical breeding grounds. The drying of wetlands has knock-on effects far beyond their borders. since they act as natural filters for water, nurseries for species, and buffers against floods. When drought silences a wetland, it is as if a vital organ has gone quiet in the body of the landscape. Wildlife responses vary widely. Some animals adapt with mobility. Elephants in Africa, for instance, travel vast distances in search of water, digging into dry riverbeds to reach hidden reserves. Birds adjust migration routes, moving toward wetter refuges when traditional stopovers fail. Amphibians, less able to wander, often survive by burrowing underground or entering states of dormancy. Insects such as locusts sometimes respond explosively, thriving in the chaotic alternation of drought and sudden rain, emerging in swarms that reshape entire regions. For many creatures, however, prolonged drought means hunger and decline. Predators suffer when prey populations dwindle and competition intensifies at shrinking waterholes. The interconnectedness of ecosystems means that drought often sets off cascading effects. Consider a forest. When trees weaken, insects invade. Birds that feed on those insects may initially flourish, but as trees die, the birds lose their habitat. As the canopy opens, the soil dries more quickly, further stressing the system. Similarly, in rivers, reduced flow concentrates pollutants and raises water temperatures, stressing fish and aquatic life. Fewer fish mean fewer meals for birds and mammals. A single dry season can ripple through the food web in ways that last for years. Sometimes ecosystems bounce back with surprising speed once rains return. Grasslands can green almost overnight, insects and birds reappear, and ponds refill. Seeds lying dormant for years burst into life, restoring colour to landscapes once thought lost. The resilience of nature is extraordinary, yet there are thresholds, and once crossed, recovery may be slow or even impossible. Repeated droughts can push grasslands toward desertification, forests toward dieback, and wetlands toward permanent loss. Human pressures often intensify these stresses. Overgrazing strips vegetation, making soils more vulnerable. Dams and diversions reduce river flows, leaving aquatic ecosystems with little margin to endure dry years. Pollution compounds the problem, as wetlands and lakes already strained by low water must also filter contaminants. Climate change, meanwhile, adds another layer, amplifying the severity of droughts and testing systems that once could withstand natural variability. There are, however, stories of adaptation and hope. Conservationists have learned to create artificial waterholes for wildlife during extreme droughts, helping species survive. Restoration projects in wetlands, such as reconnecting rivers to floodplains, can improve resilience by ensuring ecosystems hold more water when it is available. Some communities manage forests with practices that reduce stress, thinning overcrowded stands to lessen competition for scarce moisture. These measures do not eliminate drought, but they give ecosystems a fighting chance. The persistence of drought in nature also shapes culture. In Australia, indigenous knowledge speaks of waterholes as sacred, not only because they provide survival, but because they are central to the health of the land. In Africa, drought has long guided the seasonal movements of herders and wildlife alike, weaving scarcity into the rhythm of life. These traditions reflect a deep understanding that ecosystems and people are inseparably linked in their response to water. What becomes clear is that drought is both a natural process and a stress test. It reveals the hidden strength or weakness of ecosystems, exposing the delicate balance that sustains them. Some systems flex and recover, others falter, and in each case the outcome tells us something about resilience, adaptation, and the fragility of abundance. To watch a wetland shrink or a forest lose its canopy during drought may feel like witnessing decline, yet it is also a reminder of the extraordinary strategies that life has evolved to endure hardship. Seeds wait, roots stretch deep, animals move, and entire ecosystems bend toward survival. But when the sky stays silent too long, even the most ingenious adaptations are tested, and sometimes the silence of rain is louder than any sound of life In the end, ecosystems under stress remind us that water is not just a resource but the bloodstream of the living world. When it falters, every organism feels the strain, from the smallest insect to the tallest tree. And in their struggles, we see a mirror of our own dependence, for our fate is tied just as closely to the rhythm of rain and drought as the forests, wetlands, and grasslands we share the planet with. When rains fail and the ground bakes under a hot sun, the stage is quietly set for fire. Drought does not always spark the first flame, but it creates the perfect conditions for flames to spread once ignition arrives. Dry leaves, brittle grasses, and parched trees become tinder waiting for a match. In this way, drought and wildfire are close companions, one laying the groundwork, the other bringing the spectacle of destruction and renewal. The science is straightforward enough. Plants are reservoirs of water in ordinary times, their tissues containing moisture that resists burning. During drought, however, these natural defences weaken. Leaves lose water, grasses wither, and dead branches accumulate. The landscape transforms into a fuel load, primed for fire. Even a stray lightning strike or a spark from human activity can then set off blazes that race across hills and forests with alarming speed. The longer the drought, the drier and more combustible the vegetation becomes. Wildfires are not evenly distributed around the globe. They are most common in regions with seasonal dry periods, such as the Mediterranean basin, parts of Australia, and the western United States. These landscapes are shaped by a rhythm of wet and dry. Rains feed vegetation during one part of the year, and when the skies turn clear and hot, that same vegetation becomes fuel. If the dry season lengthens into drought, the danger intensifies dramatically. California, for instance, has seen some of its largest and most destructive fires during years of severe drought, when forests and chaparral were already parched. But fire is not always a villain. Many ecosystems evolved with fire as a natural part of their cycle. In Australian eucalyptus forests, oils in the leaves make them highly flammable, yet many species rely on periodic fires to clear undergrowth and trigger seed release. In the pine forests of North America, certain cones remain sealed until the intense heat of fire opens them, scattering seeds onto nutrient-rich ash. Grasslands, too, often recover swiftly after burns, with new shoots sprouting from roots protected underground. Fire, in these contexts, is both destroyer and restorer, a paradoxical force that maintains ecological health. Drought, however, changes the tempo. Instead of periodic, manageable fires, ecosystems can face infernos that are hotter, larger, and more destructive than those to which they are adapted. Trees that might withstand a low-intensity blaze can be killed outright by an intense drought-fueled fire. Wildlife that normally escapes may find the flames moving too fast. Even soils can be sterilized by extreme heat, reducing their ability to support regrowth. In these cases, the natural balance between fire and renewal is broken. The human cost of drought-driven wildfires is profound. Entire towns have been consumed in a matter of hours, as seen in Paradise, California in 2018. Smoke from massive blazes travels far, reducing air quality across continents and affecting millions of people. Infrastructure, agriculture, and economies all suffer when fire seasons stretch longer each year. Drought ensures that once a fire begins, it is harder to control, since water resources for firefighting are scarce, and the flames feed greedily on every dry branch. At the same time, drought and fire together reshape the carbon balance of the planet. Forests normally act as carbon sinks, absorbing carbon dioxide during growth. But when large areas burn, that stored carbon is released back into the atmosphere in plumes of smoke. In some years, wildfires have emitted as much carbon as entire nations, amplifying the very climate change that makes droughts more likely. It is a feedback loop. Drought encourages fire, fire releases carbon, carbon warms the planet, and warming increases drought. Wildlife often becomes the silent victim in these cycles. Animals flee from flames where they can, but many perish when drought reduces water holes and food sources even before fire arrives. After blazes, however, a remarkable resilience often shows itself. In forests blackened by fire, green shoots emerge quickly. Birds return, feeding on the insects drawn to scorched wood. Herbivores browse on fresh regrowth, and predators follow. The transformation of a charred landscape into a place of new life is one of nature's most powerful demonstrations of renewal. Still, when droughts are prolonged and fires too frequent, recovery falters and ecosystems may shift into entirely new forms. Traditional societies long understood the link between dryness and fire. Indigenous Australians practiced controlled burns, using fire deliberately to reduce fuel loads and encourage certain plants. Native American groups did the same, shaping landscapes into mosaics that were both safer and more productive. These practices acknowledged fire as an inevitable companion of dry seasons, a tool rather than an enemy. Modern fire suppression policies, in contrast, have sometimes allowed fuel to build up for decades, making drought-driven fires far more severe when they finally ignite. The challenge in today's world is finding balance. Total prevention of fire is neither possible nor ecologically wise. Allowing uncontrolled wildfires, on the other hand, leads to devastation. In an age of longer droughts and hotter summers, this balance grows harder to strike. Communities now prepare with fire breaks, evacuation plans, and early warning systems, while ecologists argue for reintroducing controlled burns. The lessons of history, that fire is inevitable and that drought makes it dangerous, remain as relevant as ever. Ultimately, the phrase "fire follows drought" is more than a description. It is a reminder that scarcity and destruction are often entwined, that silence in the skies can lead to roaring in the forests. Yet it is also a reminder of resilience, for as much as drought sets the scene for fire, and fire transforms the land, life returns again and again. Ash gives way to shoots, blackened trunks to new forests, and dry earth to green when rain finally falls. The danger lies not in fire itself, but in its intensification. Drought stretches the limits of what ecosystems can endure, turning a natural rhythm into a destructive spiral. Still, even after the fiercest blaze, the smell of smoke eventually fades, the soil cools, and the quiet work of renewal begins. Fire follows drought, yes, but so too does the promise of life finding its way back. The human cost of drought is rarely as dramatic as an earthquake or as sudden as a storm, yet it can be far more devastating. Drought seeps into societies quietly, tightening its grip over months and years until the consequences are impossible to ignore. Fields fail, wells dry, families move, and conflicts simmer. For all our technology and organisation, people remain deeply vulnerable to the long silence of rain. Food is often the first visible casualty. When crops wither and harvests decline, famine can follow. In parts of the Horn of Africa, repeated droughts have pushed millions into food insecurity. Livestock die in parched pastures, and communities that rely on agriculture are left without their primary means of survival. The images that emerge during these crises, empty grain stores, thin cattle, children malnourished, are reminders that drought is not only about water but about sustenance. Hunger does not arrive all at once but creeps into homes with each missed harvest. Migration is another consequence, one that has shaped human history for centuries. When water becomes too scarce, people often have no choice but to move. Entire families abandon ancestral lands to seek better prospects elsewhere. In the Sahel region of Africa, for instance, pastoralists have long adjusted their movements to shifting rainfall, but prolonged droughts can push them far beyond traditional routes, leading to disputes with settled farmers over land and resources. In Central America, recurring droughts have been cited as one factor driving migration northward, as families leave behind barren fields that can no longer sustain them. Movement driven by drought is rarely a matter of choice. It is a necessity born of survival. Water itself can become a source of conflict when scarcity deepens. Tensions flare between communities, regions, and even nations over rivers and aquifers. The Nile, the Tigris and Euphrates, and the Colorado River have all been subjects of political wrangling as countries and states compete for shrinking supplies. While outright water wars are relatively rare, disputes over access can inflame existing rivalries and contribute to instability. A village upstream that diverts water may leave those downstream desperate, and desperation can quickly harden into hostility. In this way, drought acts less as a weapon and more as a spark, igniting tensions that already smoulder. Inequality is perhaps the most insidious element of drought's toll. When water grows scarce, not everyone suffers equally. Wealthier households can afford bottled water, private wells, or sophisticated filtration systems. Poorer families may queue for hours at public taps, carry jerry cans long distances, or simply go without. In Cape Town during the Day Zero crisis, residents of affluent neighbourhoods often had the resources to adapt, while poorer communities bore the heaviest burdens. Rural villages in many countries feel drought most acutely, while cities, with their political influence, often secure priority access to dwindling supplies. Scarcity magnifies social divides, laying bare the fault lines within societies. The health effects of drought extend beyond hunger and thirst. Reduced water supply compromises sanitation, increasing the spread of disease. Malnutrition weakens immune systems, making communities more vulnerable to illness. In extreme cases, entire healthcare systems come under strain, dealing with the compounded challenges of food shortages, waterborne diseases, and respiratory problems from dust storms. Drought does not need to topple buildings to destabilize a society. It does so by wearing down bodies and spirits slowly, relentlessly. The psychological cost is harder to measure but no less real. Farmers watching their crops fail season after season often experience despair and hopelessness. Families forced to leave their homes carry the trauma of displacement. Children growing up in drought-affected areas may spend their formative years under the constant shadow of scarcity. The stress of not knowing if water will come tomorrow is a heavy burden, and unlike a flood or hurricane, there is no clear endpoint when the suffering is guaranteed to stop. Yet amidst these difficulties, communities often display remarkable resilience. Water-sharing agreements, community-led conservation, and innovations in farming practices can soften the blow. In some drought-stricken regions of India, farmers have revived traditional water harvesting techniques, such as step wells and tanks, restoring old systems that capture and store rain. In sub-Saharan Africa, mobile technology now allows pastoralists to track rainfall patterns and grazing conditions, helping them plan movements more effectively. Such strategies reveal that drought does not only expose weakness, it also draws forth creativity and cooperation. Still, the broader question remains: how can societies prepare for a future where droughts are expected to become more frequent and intense? Climate change is altering rainfall patterns and increasing evaporation, putting even regions once considered secure at risk. Megacities, industrial centres, and agricultural giants all depend on water supplies that may no longer be reliable. The human cost of drought in the coming century may be measured not only in crop failures and migration, but also in the difficult choices societies must make about who gets access to water when there is not enough for all. It is tempting to view drought purely through statistics: rainfall deficits, reservoir levels, tons of crops lost. But behind those numbers are individual lives: the farmer walking across cracked fields, the mother carrying buckets from a distant well, the child whose school closes because there is no water for toilets. Drought translates global climate shifts into intimate human struggles. The toll of running out of water, then, is quiet, but immense. It is not marked by collapsed buildings or roaring winds, but by the absence of what sustains life. Migration, famine, conflict, and inequality are all threads woven into the fabric of drought's impact. They show that while drought begins with the silence of skies, its echoes reach into every part of society. And perhaps the most sobering truth is that we're all vulnerable. Whether in a remote village or a global metropolis, water underpins everything we do. When it falters, so too does the delicate system of food, health, and security that we often take for granted. The human cost of drought is measured not only in statistics, but in the quiet resilience of those who endure it, and in the choices societies make to ensure that resilience is not stretched beyond breaking. Drought creeps in quietly, often so gradually that people do not notice until wells are low, crops are weak, or rivers have already begun to shrink. Unlike storms that announce themselves with thunder or earthquakes that strike in an instant, drought hides in plain sight. That is why measuring and predicting it is both essential and surprisingly difficult. Scientists have developed a range of tools to track when dryness becomes dangerous, from old-fashioned charts to high-tech satellites orbiting the Earth. Each method gives us a slightly different perspective on how much water is missing, where, and why. One of the most widely used tools is the Palmer Drought Severity Index, often shortened to PDSI. Developed in the 1960s by Wayne Palmer, this index was one of the first systematic attempts to quantify drought in a way that could be compared across regions. It takes rainfall data, temperature, and soil moisture into account, combining them into a number that tells you whether conditions are normal, unusually wet, or drifting into various levels of drought. A value close to 0 suggests balance, while increasingly negative numbers indicate growing dryness. The simplicity of the PDSI made it popular, but it has its limitations. It assumes soil and climate conditions similar to those in the central United States, which means it is less accurate in places with very different environments, such as tropical forests or deserts. Still, it remains a cornerstone in drought monitoring, especially when looking at long-term patterns. Another widely used measure is the Standardized Precipitation Index, or SPI. This one focuses purely on rainfall. By comparing precipitation over a given period, say 1 month, 6 months, or a year, to the historical average, the SPI shows whether a region is unusually wet or dry. Because it is flexible across timescales, it is especially useful for different types of drought. A short-term dip might affect crops, while a long-term deficit could stress reservoirs and groundwater. The SPI highlights both. It is a reminder that drought is not a single thing, but a spectrum of shortages playing out over different intervals. In recent decades, satellites have added a whole new dimension to drought monitoring. Instruments orbiting hundreds of kilometers above us can measure everything from soil moisture to vegetation health. The GRACE mission, short for Gravity Recovery and Climate Experiment, is particularly striking. By measuring tiny changes in Earth's gravity field, GRACE can detect shifts in the mass of water stored underground. In other words, satellites can weigh aquifers and reveal when they are losing water during prolonged droughts. This is something ground-based observations often miss, since groundwater is hidden from view. Suddenly, what was once invisible has become measurable from space. Other satellites use different tricks. Some monitor surface temperatures, since stressed plants often heat up when they close their pores to conserve water. Others capture the greenness of landscapes, showing how vegetation changes colour during dry periods. Together, these tools create a near real-time picture of how drought spreads across continents. Agencies like NASA and the European Space Agency now provide global drought maps, accessible to anyone with an internet connection, allowing farmers, policymakers, and even curious citizens to track conditions almost as they happen. Prediction, of course, is the next challenge. Knowing that a drought is already underway is useful, but knowing that one might be coming is even better. Seasonal forecasts combine ocean and atmospheric data to make educated guesses about rainfall in the months ahead. The El Niño Southern Oscillation is particularly important here. When El Niño warms the Pacific Ocean, it often shifts rainfall patterns, drying some regions while flooding others. By monitoring ocean temperatures, scientists can anticipate drought risks months in advance for places as far apart as Australia, India, and South America. Still, drought prediction is far from perfect. The atmosphere is a chaotic system, and while broad patterns like El Niño are somewhat predictable, local rainfall is not. A forecast might suggest a high chance of below-average rain, but whether that translates into a devastating drought or just a slightly dry season depends on many factors. Soil conditions, existing water reserves, and human demand all complicate the picture. Predicting drought is a bit like predicting when a slow-moving chess game will reach checkmate. You can see the direction, but the exact timing and moves are tricky. Modern technology has added new approaches to the puzzle. Climate models simulate how global warming is likely to influence rainfall and drought patterns in the coming decades. Machine learning tools now sift through mountains of climate data, spotting subtle patterns that might escape human eyes. These systems can sometimes offer more refined local forecasts, though they rely on having vast amounts of reliable data. In parts of the world where weather stations are sparse, predictions remain more uncertain. On the ground, monitoring networks remain vital. Thousands of weather stations around the globe measure rainfall, evaporation, and soil conditions daily. Hydrologists track stream flows, reservoir levels, and groundwater withdrawals. Local knowledge adds another layer, with farmers and communities observing the signs of stressed crops, thinning rivers, or unusually dry winds. Together, these observations ground the abstract numbers in lived reality. What makes drought measurement especially challenging is that it does not have a clear start or end. When exactly does dry weather become drought? There is no universal threshold. It depends on expectations and needs. A farmer may declare drought when crops begin to wilt, while a city planner might only use the word when reservoirs drop below a certain percentage. Scientists, in turn, seek standardized indices to compare across regions. The result is that drought is as much a social definition as a scientific one. Measurement tools help bridge that gap, providing common language for an elusive phenomenon. All of these tools, indices, satellites, models, serve not only scientists but also decision-makers. Governments use drought data to declare emergencies, allocate aid, and manage resources. Insurance companies use it to calculate risks. Farmers use it to decide whether to plant, irrigate, or leave fields fallow. The more accurately drought can be measured and forecast, the more chance societies have to prepare instead of simply reacting. And yet, even with all these advances, drought retains an element of mystery. It can creep in slowly, defying early warnings, or it can deepen more severely than forecasts suggested. The best tools offer probabilities, not certainties. They allow us to watch the unfolding process more closely than ever before, but they cannot remove the uncertainty entirely. Perhaps that is fitting. Drought, after all, is defined by absence, by the rain that never came. Measuring it is like measuring a shadow. You can map its edges, describe its depth, and watch it change, but it will always retain something elusive. The effort to measure and predict drought reflects a broader truth. Societies crave certainty in a world where water is never guaranteed. From hand-drawn charts in the 20th century to satellites weighing aquifers in the 21st, the quest continues. Each tool sharpens the picture, giving us a better chance to anticipate the silence of the skies. But no matter how sophisticated our methods become, drought will always be a reminder that some forces remain partly beyond prediction, and that resilience requires not only knowledge but humility in the face of nature's subtle rhythms. When the rains fail, people rarely accept dryness as fate. Across history and into the modern age, societies have found ways to stretch scarce water, to store it when it comes, and to squeeze every possible drop from the landscape. Drought may be natural, but human beings have always tried to outwit it with engineering, ingenuity, and restraint. The results are reservoirs and dams, groundwater pumping schemes, desalination plants, and conservation campaigns that together form the toolkit of resilience. Reservoirs are perhaps the most visible of these tools. By capturing water in vast artificial lakes, societies create buffers against the unpredictability of weather. A good rainy season can fill a reservoir that then supplies farms and cities during leaner times. The Hoover Dam on the Colorado River is one of the most famous examples, forming Lake Mead, which has long sustained millions of people in the American Southwest. Similar structures dot the globe, from the Aswan High Dam on the Nile to China's Three Gorges Dam. These projects provide not only water but also hydroelectric power and flood control. Yet they are not invincible. When drought stretches for years, even giant reservoirs can shrink to alarming levels, exposing bathtub rings on canyon walls and leaving marinas stranded on dry ground. Groundwater has often been the hidden reserve in times of scarcity. Aquifers beneath the surface hold vast amounts of water, stored over centuries or millennia. In dry years, wells tap into these underground reserves to keep crops alive and cities supplied. The Ogallala Aquifer beneath the Great Plains of the United States transformed the region into a breadbasket, once pumping technology became widespread in the 20th century. But groundwater is a finite resource. In many places it is being extracted far faster than it is replenished. As water tables drop, wells must be drilled deeper, and eventually the supply dwindles. It is like living off a savings account without income to replace what is spent. Effective for a while, but unsustainable in the long run. Desalination has emerged as a modern solution for regions with more seawater than rainfall. By removing salt from ocean water, cities in arid climates can create new supplies independent of weather. The Middle East has embraced this technology, with Saudi Arabia, the United Arab Emirates, and Israel relying heavily on desalination plants. In drought-prone California, desalination is also used as part of a broader portfolio of water strategies. The advantage is clear. The ocean is essentially limitless. The drawback is cost and energy. Desalination requires significant power and infrastructure, making it expensive compared to traditional sources. Still, as technology improves, the process is becoming more efficient, and for many coastal cities it has become a crucial lifeline. Conservation is less dramatic than dams or desalination, but often more effective. Reducing water use stretches existing supplies further and avoids the environmental costs of large infrastructure. During Cape Town's Day Zero crisis, residents slashed consumption by half through restrictions and public campaigns. In drought-stricken California, households swapped lawns for drought-tolerant landscaping, installed low-flow fixtures, and embraced water recycling. Agriculture, which consumes the majority of freshwater globally, has adopted methods such as drip irrigation, which delivers water directly to plant roots, reducing waste from evaporation. These small adjustments add up to significant savings, proving that sometimes the most powerful tool is not building something new, but simply using less. Innovation has also turned toward recycling and reuse. Wastewater treatment plants now produce water clean enough for irrigation, industrial use, or even drinking after advanced purification. Singapore is a leader in this area, promoting any water, recycled water that supplements its limited rainfall. This approach reframes the concept of waste, transforming it into a renewable resource. Similarly, stormwater harvesting captures runoff from streets and rooftops, channeling it into reservoirs or underground tanks instead of letting it rush away unused. Community-level strategies remain important too. Traditional water management systems like the step wells of India or the qanats of Iran reveal that resilience is not only about modern engineering, but also about cultural knowledge. Reviving or adapting these techniques can provide sustainable solutions in places where high-tech systems are too costly. Local cooperation, whether through shared irrigation schedules or communal reservoirs, often proves as critical as any dam or pipeline. Yet every strategy carries trade-offs. Dams can disrupt ecosystems and displace communities. Excessive groundwater pumping causes land to sink and aquifers to collapse, Desalination can harm marine life with brine discharge. Even conservation can strain social equity if restrictions fall unevenly on different groups. The challenge lies in balancing immediate needs with long-term sustainability. Resilience means not only surviving the current drought, but also ensuring that future generations have enough. Technology continues to expand the options. Remote sensing satellites allow managers to track soil moisture and groundwater depletion in near real time. Artificial intelligence can optimize irrigation schedules based on weather forecasts. Farmers can use sensors buried in fields to know exactly when plants need water and when they do not. These advances add precision to practices that were once based mostly on observation and guesswork. At its heart, however, fighting drought is about more than tools. It is about mindset. Societies that view water as limitless are always vulnerable. Those that accept scarcity as normal are better prepared. In Israel, for example, a culture of conservation was fostered from the nation's founding, and today the country recycles a far higher percentage of its water than most. In contrast, regions that built sprawling suburbs and lush golf courses in arid climates often find themselves scrambling when drought strikes. Attitudes toward water, whether it is seen as a gift, a commodity, or a right, shape how resilient a society can be. What is remarkable is that despite the severity of droughts, humanity has consistently found ways to adapt. From ancient canals to modern desalination plants, from shared wells to global monitoring networks, the story of water management is one of creativity in the face of scarcity. Yet the struggle is ongoing. Climate change is intensifying drought in many regions, making resilience more important than ever. The lesson is clear. We cannot control when the rains will fall, but we can control how wisely we use what we have. So when drought tightens its grip, societies do not simply wait for clouds to gather. They build, conserve, recycle, and adapt. The battle is never truly won. There will always be another dry season, another test of endurance. But each effort, each innovation, each drop saved is part of a collective attempt to outsmart the silence of the skies and to ensure that even in times of thirst, life can carry on. The climate of the Earth has always shifted, but in recent decades human activity has nudged the system into unfamiliar territory. Rising greenhouse gas concentrations are heating the atmosphere and oceans, and with that heat comes disruption to the ancient rhythms of water. Drought, long a natural companion of weather cycles, is now taking on new forms, shaped and sharpened by a warming world. To look at the future of drought under climate change is to see both the intensification of familiar patterns and the emergence of risks we have never fully faced before. One of the most fundamental changes is that warm air can hold more moisture than cool air. For every degree Celsius of warming, the atmosphere can carry roughly 7% more water vapour. This does not mean that every place becomes wetter. Instead, it amplifies contrasts. When moist air rises, the resulting storms can become more intense. When dry air descends, it becomes drier still. The outcome is a world of sharper extremes, deluges in some regions, parched silence in others. Rainfall itself is shifting in both timing and distribution. Many regions that already experience seasonal dry periods are finding them lengthening, while wet seasons can arrive later or be less reliable. The Mediterranean, parts of southern Africa, and the American Southwest are all projected to see declines in rainfall, while some higher latitude regions may grow wetter. What this means is that old assumptions about when and where water will appear no longer hold. Farmers who once counted on reliable seasonal rains now face uncertainty, and water managers must plan for variability rather than stability. Heat also accelerates evaporation, pulling water more quickly from soils, rivers and reservoirs. Even if rainfall totals remain steady, hotter conditions can tip landscapes into drought because water is lost faster than it can be replaced. This phenomenon is sometimes called hot drought. In the American West, for example, recent studies suggest that rising temperatures are already reducing river flows, even in years with average precipitation. The Colorado River, lifeblood for millions, is shrinking not only because of low rainfall, but also because heat is making the land thirstier. Glaciers and snowpacks, long-term water banks for many regions, are also at risk. In mountain ranges from the Andes to the Himalayas, communities have depended on gradual melt to feed rivers during summer months. Warming is reducing snow cover and accelerating melt, meaning more water rushes downstream in spring but less remains later in the year. This creates a double challenge: floods when water is not needed, followed by drought when it is. Old water systems designed around predictable cycles are increasingly mismatched to new realities. Climate change also influences large-scale patterns like the El Niño Southern Oscillation. These swings between El Niño and La Niña already bring dramatic shifts in rainfall across the globe. Evidence suggests that warming may be altering their frequency or intensity, although exactly how remains an area of active research. If El Niño events grow stronger, some regions could see more severe droughts, while others might experience heavier floods. The unpredictability itself is a burden, leaving societies less able to plan for what is coming. Urban areas face unique vulnerabilities. Megacities built on assumptions of abundant supply may find their reservoirs and aquifers insufficient. Cape Town's day, zero crisis, was a glimpse of what could happen when drought intersects with rapid population growth and climate stress. Cities like Sao Paulo, Los Angeles, and Mexico City already rely on complex networks of dams, tunnels, and pipelines to quench their thirst. As warming alters rainfall patterns, these systems may prove inadequate. Engineers can expand infrastructure, but without rainfall to fill it, even the largest reservoir becomes nothing more than a dry basin. Agriculture, too, is on the front line of climate-driven drought. Crops evolve to flourish under particular seasonal conditions. Wheat, maize, and rice all depend on water arriving at the right stage of growth. A drought at planting or flowering can mean catastrophic losses. Warming not only increases the risk of such events, but also shifts the geography of suitable farmland. Regions that once produced bumper harvests may become marginal, while other areas could open up. For farmers, this is not just about adjusting crops but rethinking entire livelihoods. The future of drought is also entwined with inequality. Wealthy nations and cities can invest in desalination, recycling, and advanced irrigation. Poorer regions often cannot. The same drought that means shorter showers in one country can mean famine in another. Climate change magnifies these disparities, threatening to deepen global divides. It also raises the risk of conflict as nations and communities compete for shrinking rivers or groundwater. Already, water-sharing agreements are under strain in places like the Nile Basin, where upstream dams intersect with downstream dependence. Still, it would be a mistake to view the future as only grim. Adaptation is possible, and resilience is not a lost cause. Improved monitoring and prediction, smarter farming practices, and new technologies all offer tools to manage scarcity. Yet the challenge is not only technical but cultural. It requires shifting mindsets from assuming stability to planning for variability. It means valuing water not as an infinite commodity, but as a fragile thread binding climate, ecosystems, and society. Perhaps the greatest uncertainty is how fast and how far change will go. Some models suggest that megadroughts, lasting decades, could become more common in regions like the western United States and Australia. Others warn that subtropical dry zones may expand poleward, pushing arid conditions into areas once considered temperate. The picture is not uniform. Some places may indeed become wetter, but the overall theme is greater volatility. Water security in the future will hinge not on averages but on extremes, whether societies can survive the dry years without collapsing. What climate change reveals is that drought is not merely about missing rain. It is about the entire balance of the water cycle under strain. Heat intensifies evaporation, glaciers vanish, rainfall shifts, and ecosystems buckle. Old systems built for yesterday's climate are being tested against tomorrow's. Some will bend, others may break. To imagine the future of drought is to imagine a world where uncertainty becomes the new normal. Reservoir levels swing wildly, crops succeed one year and fail the next, and rivers reach the sea only intermittently. It is a world that demands flexibility, creativity, and cooperation. While drought may always be a companion to humanity, climate change ensures that this companion is becoming less predictable and more demanding. And so, the question facing us is not whether drought will continue. It will, but whether societies can learn quickly enough to live with its new face. The warming world is rewriting the rules of rainfall and dryness, and in that rewriting lies both peril and opportunity. If we adapt wisely, drought can remain a challenge we endure. If not, it may become one of the defining crises of our century. For all the hardship that drought brings, it also reveals something remarkable about life, its determination to endure. Scarcity forces creativity. Dry skies compel cooperation. The absence of water, instead of silencing the world, often draws out some of its most resourceful responses. The geography of hope is written in terraces carved into hillsides, in ancient canals still flowing, in modern cities recycling every drop, and in communities that learn to share rather than compete. Across the world, people have turned drought into a challenge not only of survival, but of ingenuity. In Rajasthan, India, where monsoon rains can be fleeting, villagers have revived the ancient practice of building johads, small earthen dams that capture seasonal rainfall and recharge groundwater. These modest structures, built by hand, have transformed once dry landscapes into fertile ground. Rivers that had run dry for decades have begun flowing again, and farmers can plant with confidence. It is not technology that made the difference, but local knowledge, patience, and collective action. In Israel, a country with limited natural water resources, innovation has turned scarcity into opportunity. Drip irrigation, invented there in the 1960s, delivers water slowly and directly to plant roots, dramatically reducing waste. The technique has since spread across the globe, allowing crops to grow in places that would otherwise be barren. Israel also leads the world in water recycling, treating wastewater until it is safe for agriculture. Fields of citrus and olives thrive not because the land is wet, but because water is used with extraordinary care. Scarcity became the seed of invention. Africa too has countless examples of resilience. In Niger, farmers have embraced a technique known as farmer-managed natural regeneration. By protecting and pruning tree stumps in their fields rather than cutting them down, they have encouraged millions of trees to regrow across once barren land. These trees shade crops, improve soils, and help retain moisture. What began as a grassroots practice has now restored landscapes across thousands of square kilometres, showing that even in drought-prone regions, renewal is possible when people and ecosystems work together. There are stories of cooperation on a larger scale as well. Along the Murray-Darling Basin in Australia, competing demands for water once pitted farmers, towns, and ecosystems against each other. Today, after years of conflict and crisis, water-sharing agreements and environmental flows have begun to rebalance the system. Rivers are being managed not just for irrigation, but also for the wetlands and wildlife that depend on them. It is not a perfect solution, debates still flare, but it represents a recognition that water cannot be treated as an endless commodity. It must be shared, carefully and deliberately. Cities are also finding ways to adapt. In Singapore, where natural freshwater supplies are limited, the government developed a strategy known as the 4 national taps. Water comes from local catchments, imports, desalination, and recycled sources, each complementing the others. By diversifying supply and investing in infrastructure, Singapore has insulated itself against drought in ways few cities have matched. What might have been a vulnerability became a model of resilience. Nature itself offers hopeful stories. After severe droughts in parts of the American West, wetlands restored by conservation groups have rebounded astonishingly quickly. Once water returned, birds filled the skies again, amphibians bred in temporary ponds, and grasses reclaimed cracked mud. These recoveries show that ecosystems, though fragile, also hold a quiet tenacity. If given the chance, they can bounce back from even prolonged stress. The geography of hope is not only about large-scale projects but also about daily choices. Families installing rain barrels, farmers planting cover crops, communities protecting forests that regulate rainfall. Each small act contributes to resilience. In Cape Town during the Day Zero crisis, residents reduced their personal water use to levels once thought impossible. People showered in buckets, reused grey water, and accepted brown lawns as the price of survival. In doing so, they demonstrated that behaviour can change when necessity demands it. The crisis passed, but the lesson remains: collective discipline can avert disaster. There is also an emotional resilience worth noting. Communities enduring drought often respond with solidarity rather than division. Neighbours share water, towns rally around struggling farmers, and cultural traditions reinforce respect for this most precious of resources. Songs, rituals, and stories about rain remind people that scarcity is not permanent, that endurance is possible. These intangible forms of resilience, hope, patience, community, are as critical as dams or desalination plants. Looking to the future, the challenge is immense. Climate change promises more frequent and severe droughts in many regions, testing both old and new systems. Yet the past and present are full of proof that societies can adapt. With knowledge, cooperation, and innovation, drought does not have to mean disaster. It can instead be the pressure that shapes smarter farming, fairer water policies, and stronger communities. At the same time, drought reminds us of our place in the wider web of life. Just as trees close their pores to conserve moisture, or animals migrate to find new waterholes, humans too must adjust. Resilience is not about conquering nature, but about moving with its rhythms, even when those rhythms include silence. By learning from ecosystems that have thrived in arid lands for millennia, people can find strategies that are both effective and sustainable. As the story of drought unfolds, it is tempting to focus only on the losses, the failed crops, the dry rivers, the empty reservoirs. But the geography of hope shows another side. Wells dug deeper, seeds planted with care, agreements forged across borders, and technologies born from necessity. These responses reveal that life, when tested, does not give up easily. And so, the final reflection is calm but resolute. Drought is a harsh teacher, stripping away illusions of abundance and reminding us of our dependence on water. Yet in that challenge lies creativity and strength. Time and again, people and ecosystems have endured, adapted, and renewed themselves. The geography of drought may be marked by scarcity, but the geography of hope is mapped in resilience. It tells us that even in the driest times, life finds a way forward. Water is so ordinary in daily life that it often feels invisible. It trickles from taps, fills glasses, soaks into fields, and disappears down drains without much thought. Only when it falters does its quiet centrality become clear. Drought reminds us of this truth in the starkest way. It arrives slowly, empties rivers, silences wetlands, and presses itself into every part of life. And yet, as harsh as it is, drought is also a teacher. It shows us that the balance between abundance and scarcity is fragile, that resilience comes from adaptation, and that both nature and humanity possess extraordinary creativity in the face of hardship. Looking back across the landscapes we have explored, one sees a pattern that is both sobering and hopeful. Deserts that seem barren have long been home to ingenious communities who carved cisterns, built qanats, and guided caravans by memory. Civilizations that once flourished, the Akkadians, the Maya, the Puebloans, remind us that drought can test even the mightiest societies, sometimes beyond their limits. Modern cities like Cape Town or Sao Paulo, which stood at the edge of running dry, show how fragile urban systems can be. But alongside this fragility lies persistence. Farmers revive old water harvesting traditions. Engineers recycle every drop through sophisticated systems. Neighbours share buckets and wells, proving that community is often the strongest reservoir of all. The Earth itself tells the same story. Ecosystems bend under drought but often do not break. Grasslands wait patiently beneath the soil until rains return. Wetlands fall silent, then sing again with birds when water flows back. Forests may thin, but shoots of green still emerge from blackened earth after fire. The planet remembers how to recover, even if the scars remain. In this resilience, there is a quiet reassurance. Droughts pass, and life has ways of returning. And yet, the lesson is not only about survival. Drought is also a mirror, reflecting the ways we use, waste, and value water. It asks uncomfortable questions. How much can we demand from rivers before they fail? How fairly do we share what is scarce? How can societies prepare for scarcity without waiting for crisis? These questions linger long after the rains return, shaping how we plan cities, grow food, and think about the future. They reveal that drought is not just about climate and soil, but also about choices and priorities. Climate change sharpens this mirror. Warmer temperatures, shifting rainfall, and melting snowpacks mean that droughts in the future may be harsher and more unpredictable. Old patterns of water management no longer guarantee safety. Reservoirs built for yesterday's climate strain against tomorrow's uncertainties. But even in this, there is a chance for renewal. Scarcity can inspire innovation, and hardship can remind us of what matters most. The fragility of water systems can also be their strength, pushing societies to cooperate, to conserve, and to treat water not as endless but as precious. There is hope in knowing that we have endured before. The Dust Bowl gave rise to new soil conservation practices. Ancient techniques of rainwater harvesting are being revived in modern villages. Technologies like drip irrigation, desalination, and water recycling are spreading across the globe. The story is not one of defeat, but of constant adaptation, of finding ways to live within the shifting boundaries of nature. And there is a deeper hope, too, in the humility that drought instills. When skies are empty and rivers shrink, humans are reminded that control is an illusion. Water has always moved according to its own rhythms, guided by winds, oceans, and clouds. To live with drought is to accept that uncertainty is part of life. It is an invitation to patience, to stewardship, and to balance. Perhaps the most profound lesson is that resilience is not loud. It does not always appear in towering dams or gleaming technology. Often, it is found in quiet acts: a family saving greywater, a farmer planting shade trees, a community digging a shared well, a neighbour offering a drink. These small gestures ripple outward, sustaining life through the dry times until abundance returns. In that way, drought teaches not only about scarcity, but about solidarity. As the journey through Drought's geography draws to a close, it is worth resting in the calm truth that water, like life, is cyclical. Absence is never permanent. Rains return, rivers swell, fields bloom again. In between, the world waits, sometimes in silence, sometimes in struggle, but always with the possibility of renewal. This rhythm has shaped landscapes for millions of years, and it continues to shape us today. To sit with the thought of drought is not to dwell on despair, but to recognize resilience. The cracked soil will one day soften, the empty reservoir will refill, the parched tree will send out new leaves. And humanity, tested by dryness again and again, will continue to adapt, finding ways to endure with patience and creativity. So let the reflection end gently. Drought is a challenge, yes, but also a reminder of life's tenacity. It shows us how delicate the balance of water is, how easily it can tip, and how deeply everything depends upon it. But it also shows us that even in the harshest conditions, survival is possible, and renewal is never out of reach. The Earth is resilient, and so are we. And with that thought, let the story settle, like evening rain finally returning after a long dry spell, bringing quiet comfort to the land and to the mind.